Okay, ladies and gentlemen, I'm sorry for waiting, and we are ready to start. So thank you very much for introduction, and thank you very much for great introduction and all messages from me. We are happy to be here, and I really appreciate the question of Fajar. Thank you for arriving, and I'm so happy to be here. And main purpose of this symposium is to discuss the current situation in Indonesia. But subject is to introduce the student how to come to Japan. Okay, so because our Japan's new policy is river basin disaster resilience and sustainability by all. So all means everybody. And sitting here. So we have changed our policy. So this is our previous flood control policy. This is we made a wide and dredge rivers to include flood capacity. And because of this is a death toll and a missing person, and damage cost is decreasing. You know, from 1965 to the 1995, death toll by the natural disaster was increased from 10,000 to about 10. So we are happy to say this is our victory of civil engineering against natural disaster. Okay? But now, due to the climate change, our damage has been increasing. So now we have a lot of flood disasters in Japan. Like this situation, many flood happening. Right? That's too many. So, due to climate change, magnitude and frequency of the floods are unbelievably increasing. However, there is no space and budget to increase flood capacity in rivers and the storage volume basin. We cannot make any more dams and widen rivers. So new policy has started river basin disaster service by all. By all means, we have to fight using several dams and the paddy field and the evacuation from the local people. So I would like to ask Dr. Koyama-san and my student, what's the example of those? So my topic is just an introduction. So we have now changed our policy to fight against the flood by all. Previously, we only fight against the flood by river managers, but we gave up. You know, we gave up and we asked local people and other public facilities, like the agriculture sector, to support us. Otherwise, we cannot win against climate change. So this is the meaning of by. Okay, so I would like to my student to show the examples. Maybe this afternoon sessions. Okay, that's all for my presentation, and I would like to invite Dr. Idham. Please stand up. He graduated from Tohoku University in Japan. This is the #1 university in Japan, and he got a PhD from me. And I'm so happy to see him. Okay, please give us a cut. And please make a presentation. Okay, please make a presentation. Please copy the file in here. And please give me some time. Sorry, this is Dr. Indra. posisinya begitu. Maybe you can maybe please do. Fajar, ya. Yes, next presenter is Dr. Idham-san. Bukan dulu. Bawa Gede sih. Ini tuh. Ini Pertamina tuh. Oh itu. Di sini kebetulan judul saya pengembangan serta daya banjir di Pulau Kalimantan. Jadi Pulau Kalimantan kenapa saya ambil di sini karena sekarang kita lagi ramai-ramai dan saya bekerja di Kementerian Pekerjaan Umum dan Perumahan Rakyat. Kebetulan di Daerah dan jadi pembangunan pendidikan yang mungkin teman-teman Next. Dan mungkin apa namanya kegiatan yang pekerjaan ataupun studi yang dilakukan. Jadi teman-teman bisa lihat alur kegiatan ataupun studi ataupun pemikiran yang saya tumpahkan ke dalam PPT ini. Kira-kira di sini itu banyak sekali yang informasi yang bisa lakukan apa namanya mulai dari banjir genangan, terus berapa banyak banjir yang terkena di masing-masing kecamatan di Pulau Kalimantan tersebut, lalu bagaimana kita Which one is on Zoom? Di Pulau Kalimantan dan ini seluruh Kalimantan nanti ada beberapa jas mungkin teman-teman kalau menjadi sebuah teman-teman dari Indonesia kita sulit memahami sistem gas ataupun gas di dalam satu daerah. Next.
ini kalau teman-teman lihat di Kalimantan itu salah satu pakai Tamando ya, terlihat bahwa mereka apa namanya gampang bukan gampang, maksudnya terlihat ada kejadian banjir yang cukup besar, dan kalau dilihat di gambar ada daerah jalan tersebut dan terbatas gitu. Ini mengindikasikan salah satu gambar yang saya dapat itu kejadian banjir pada saat apa namanya pada saat itu hujan yang sangat deras. Ini apa namanya salah satu perbandingan untuk
宮田聞こえる。宮田聞こえる。テストです、テスト。宮田聞こえる。宮田聞こえる。
lokasi yang saya ambil gambar yang ada di sebelah ini.
Tes, tes.
Next. Next. Tambah. Oke, jadi kira-kira saya sudah mengecek beberapa literatur, beberapa informasi apa namanya studi. Kira-kira saya singkat aja simpulannya bahwa tidak ada satupun atau sangat minim studi yang mempelajari tentang apa namanya data-data hidrologi yang ada di lapangan itu belum pernah dimanfaatkan. Nah, untuk itu salah satu lainnya adalah bagaimana dengan memanfaatkan data tersebut kami di Kementerian PU bisa mengembangkan suatu peta bahaya banjir karena sangat minim sekali data-data hidrologi yang ada. Jadi kalau diketahui banyak banyak alasan atau banyak catatan dengan keterbatasan data, tapi kok apa namanya kita sulit sekali mengatakan bahwa kita bisa membuat suatu analisa yang mungkin bisa dihasilkan dengan baik. Selalu alasannya misalnya diminta bisa nggak buat datanya kurang Pak, dari ini Pak, sama aja kayak sebenarnya kamu gimana bisa sekolah, nggak ada duit Pak, itu sama sebenarnya situasinya. Tapi ini saya tumpahkan ke dalam imajinasi apa namanya external. Oke, next. Oke, next. Next aja. Ini sistem sungainya dulu ya, saya jelaskan. Next. Nah ini ada 3 das, kebetulan 3 das di sini ada yang hijau, yang warna-warna itu. Kira sistem sungainya yang sebelah kanan ini saya pecah-pecah. Gitu. Next. Nah ini ada interkoneksi di das tersebut. Interkoneksinya yang sebelah kanan itu, nah ini menjadi catatan dalam satu catchment karena di Pulau Kalimantan itu kecenderung lebih datar, gitu. Jadi banyak interkoneksi di antara sungai gitu. Nah ini salah satunya terjadi di das yang warna biru. Next. Next. Next lagi. Oke. Nah ini perubahan iklim yang pernah dilakukan sebenarnya dibantu Pak Fajar ini tahun 2018 kita memproyeksi perubahan iklim dari tahun 1985 ke tahun 2015 dibandingkan dengan tahun 2060 ke 2100. Nah ini bisa terlihat bahwa di lokasi studi yang hitam itu curah hujan di tahun 2060 sampai 2100 itu bisa meningkat hingga 31%. Jadi katakan hujannya hari ini 1, ya berarti 30% itu 1,3. Kira-kira begitu. Ya. Di lokasi itu aja, nanti saya nggak ngomong standar secara umum, secara khusus. tapi ngomongnya hukum dan khususnya ada di tes yang saya terima. Oke, next. Nah ini saya zoom out lagi. Terlihat bahwa klasifikasi gas pertama ini, gas kumai sama gas bulu kecil itu dibandingkan perbandingan antara tahun data 2045 dibandingkan dengan data tahun 2060-2019 itu bisa terlihat di masing-masingnya bagian hulunya naik hingga 39% dan bagian di gas kota Waringin itu bisa naik 39%, di gas Kumai yang tengah itu bisa naik sekitar 15%, dan di gas hulu kecil ini yang bagian hilir ini yang bagian di bawah itu bisa naik sampai 50%. Jadi masing-masing gas itu punya karakteristik ataupun kemungkinan kenaikan iklim yang berbeda-beda. Jadi nggak sama semuanya. Ya. Next. So this may because the high resolution of the pictures, it may not show. Okay, jadi this is reduce categorized of anti catchment. Kota Waringin, Kumai, sama kecil. Dan itu saya pisahkan klasifikasi catchment ini gambarnya nggak kelihatan karena resolusinya sangat tinggi. Jadi nggak tahu situasi komputernya bagaimana saya nggak bisa tahu. Tapi harusnya kelihatan. Thanks. Nah ini lagi harusnya kelihatan. Oke, next. Next. Nah ini saya menggunakan rumusan dari yang profesor saya kembangkan. Jadi ada Renforano, ada Blamuting, sama model bintang ada. Kebetulan profesor saya ini ngembangin dan bersama saya juga ngembangin beberapa apa namanya persamaan yang ada di studi ini. Next. Next lagi. Next. Oh, aku kelihatan semua ini. Next. Nah. Apa? Ada tapi nggak apa. Next. Saya mau. Bisa melihat saya. Next problem. Coba diganti aja. Saya mau kita coba dari depan.
Oh, okay. Maybe maybe change speaker.
Change speaker.
Yes, Dr. Naoki. Perhaps. Then please prepare your file.
Okay. So I'm trying to invite perhaps and please prepare your file. Maybe say in the PDF format. In this here. See. But I'm the day there. What should we do? Here we can see very clearly. Yeah. Okay. Zoom slot. Oh, Betul ya, no?
さっき入れたやつどこ入れたやつさあ入れたやつどこにあるんですか？
I think I can continue my presentation. Mana ini?
Indra,
No. PPT.
Dipindah aja ke sana, nggak bisa. Biar juga fokus juga.
yeah, but what do you think? Oh, I see. That is much better. Sorry. The laptop that
Invite him to, yeah. Yes. Ini cuma untuk penelitian doang kan? Cuma. Ini slide to slideshow-nya di setting dong. Yang to Windows. Tapi nggak bisa itu.
Oke. Aturan deh.
Oke, もう一回やり直します。
Ageng, Kure.
Ini kan betul. Ya. Kemana? Betul. Hardware. Please check his file.
Yeah, it's already.
Yeah, it's
Fine.
It's what? PDF ya, Pak?
Iya.
Enggak yang ditujuin PDF ya?
Enggak, ini PowerPoint kok.
Hah?
PowerPoint.
Bisa?
Bisa.
Enggak di halaman-halaman tengah. Tadi kan halaman tengah.
Iya. Sebentar. Add device ya. Apa?
Hardware.
Buat setting listrik, setting charger. Oke, dan
Ini Bang, pada belum?
Um, just try. Coba aja dulu sekarang. Coba sekarang kan. Ayo coba.
Tes.
When you have ya, iya. Session langsung mulai. Speech. Buat apa ini? Bagaimana? Ya, apa dari sini?
Kalau dari sini dia echoing, Bang. Karena kan dia sekitar hidup. Kita ngomong, dia dimatiin, mic yang di sini kita matiin. Kita pakai mic yang di sana.
Ladies and gentlemen, sorry for the misconvenience, but now that everyone has enjoyed their break, we will continue our session. So I would like to ask Dr. Idham Riyando to take over the event once again.
Giliran aja. Giliran lagi. Siapa ya?
Assalamualaikum warahmatullahi wabarakatuh. Mohon maaf ya tadi.
Gambarnya banyak yang lost
Lost
ya.
ya. Ini udah
Bisa ya,
terus
terus ya,
kita mulai aja lagi. Mungkin tadi sudah sedikit ya. Jadi ada beberapa das yang saya evaluasi di sini. Ada 3 das berdekatan atau tetangga di situ. Mungkin next. Jadi 3 das tadi yang kelihatan di situ ada
das kuman, das
bawah ini das bulu kecil di sini. Kota ini catchment kuman, catchment
bulu kecil.
next. Nah ini
sebenarnya whole catchment itu kelihatan di sebelah kiri. Nah, but I selected several catchment, only several catchment, 3 catchment, go to times boundary. Jadi kita ada punya waktu sedikit untuk melakukan riset, studi. So finally we selected those 3 catchment, small catchment. Catchment Kota Waringin, catchment Kumai, sama catchment Bulu Kecil. Next. Nah, ini dia. So, kalau dilihat, so we have several district which very risky with flood. So every kecamatan ini sangat rawan terhadap potensi banjir yang ada di desa tersebut. Jadi kalau dilihat kan di mana ada sungai, ya kita sebenarnya sangat risiko karena kita sangat bertetangga sama sungai itu. Jadi saya mengklarifikasi bahwa all district in those 3 catchment are risky with flood. Ya. Jadi jadi sungai-sungai ini das Kota Waringin, das Kumai, sama das Bulu Kecil. Jaringan sungainya all rivers networks you can see on the right side picture. Okay, next. Oke, nah ini Kalimantan seluas itu. But I selected only small catchment. My study case on the Kalimantan hari ini. Actually, we already did whole small catchment, but I only show for you guys as a good example. So jadi ini hanya 3 das dari banyak das yang dikerjakan. Itu imajinasi teman-teman benar apa namanya from small world, and small world. So we have a big picture of the result. So this is only small world from me, as you can see as example. So you can contoh buat teman-teman kalau tertarik beli bidang istilah. Okay, next. The next side picture is the name of the river. Nama-nama sungai. Terus, okay, next. Okay, next. Ya, next lagi. Next. Nah, ini sistem sungainya. Jadi ini dasnya, das tersebut bisa apa namanya bisa dibagi lagi sebagai das. Ya, ini sebelah kanan. Next. Nah, ini there is an interconnection between the rivers. So this interconnection is very important because almost all Kalimantan island and downstream is very flat, really flat. So this interconnection play important point rules di apa namanya di network ini. Oke, next. Next. Nah, ini hujan yang ada di apa namanya informasi hujan bulanan yang ada di das Kotawati, das Kumai sama das Gede.
Nggak serius-serius banget.
Bisa dilihat ada bulan-bulan tertentu
berkecil hati.
Dia hujannya tinggi dan itu terindikasi akan adanya potensi banjir di situ. Jadi di bulan-bulan itu teman-teman bisa membayangkan bahwa akan terjadi potensi banjir yang tinggi. Next. Nah, ini tadi yang saya sudah jelaskan, ada potensi. Bayangkan bahwa di tahun 1985, tahun 2015 hingga tahun 2015 itu nilai hujannya datang X, tapi ketika di tahun yang akan mendatang itu meningkat hingga 30%. Tapi saya mengambil contoh case untuk di das 3 itu aja. Dan itu mungkin berbeda kejadiannya ketika di daerah lain yang kita ambil. Teman-teman bisa lihat distribusi of the rainfall pattern, ya. Nah, pola hujannya bisa kelihatan di sini. Ini yang lalu kira-kira yang ke depan begitu ya. Itu kita lakukan sebagai proyeksi. Proyeksi itu something unclear, tapi kita bisa
kalau nggak ada
apa namanya bisa mengatakan bahwa ada kenaikan seperti itu. Oke, next. Nah, ini saya zoom in. Kira ini kenaikannya di tahun-tahun yang akan datang sebelah kanan. Ini yang tengah itu historik situasi saat ini historical. Ya. Tadi saya sudah jelaskan ada kenaikan curah hujan.
Nanti aja sih.
Next. Nah, ini radius
Tenang aja.
apa namanya radius klasifikasi untuk ketiga catchment tersebut. Das Kumai, das Pertamina sama das Indra. Nah, ini saya dapat dari Sentinel 2 dan itu sebenarnya bisa di-download, teman-teman bisa download itu ya. Dan itu ini radiusnya ya, kita terus saya menghitung di masing-masing itu berapa sih angkot, berapa sih beban, berapa sih aktivitas, berapa sih polres, berapa sih kuota. Next.
Kan jadinya tetap aja next
Nah ini situasi di A itu banyak pertanian,
Jadi pada shot
terus yang di B ini itu juga banyak pertanian. Saya pilih-pilih aja, pilih-pilih
Jadi gunanya dong.
beberapa gambar untuk ditunjukkan. Jadi saya ambil dari Bogor. Nah, di sini pun kalau di B ini itu banyak tumbuhan, banyak apa pohon-pohon kecil dan sangat jarang penduduk di sini. Next, nah ini kalau di zoom itu
Kamu pernah pakai dua screen gini kan?
lebar bunganya udah 300
Ya,
meter, tapi bisa
belajar
masih
tuh.
sering terjadi kejadian banjir.
Nah udah
Ini
keluar
mungkin
masuk
mereka
offline.
juga tinggal di
Nanti kamu kerja presentasi enaknya kayak gitu.
So,
Jadi double
banyak orang, many people stay alive, stay live with the
ini nih ada screen ini satu. Screen ini tuh ini.
riparian river. Ya, di pinggir-pinggir apa namanya daerah. Kalau kita tuh sempadan sungai istilahnya. Itu mungkin itu padahal sungainya itu ada 300 meters. But still it happens ya. What happen on those area. Oke, next. Ini sudah 630 meter, tapi juga sering terjadi banjir di daerah ini. Next. Nah, ini kecil banjir. Jadi juga banjir di situ. Tapi daerah ini, there is no people stay here. Tapi kalau we as the Ministry of Public Works, as the Directorate General of Water Resources, ya SDA, negara lain, kita mempersiapkan preparing the flood map on those whole area under our responsible territory. Ya. Walaupun situasinya orangnya nggak ada tinggal di sini. Next lagi. Ini tadi model yang digunakan. Next lagi. Ini juga yang teman-teman saya pikir belum belajar ya, kata Yasu dan segala macamnya. Next. Nah ini nanti Pak Rutin sama Pak Indonesia bisa ke Dokter Fajar tuh dijelasin banyak. Nah, ini ya apa namanya teman-teman bisa menggunakan banyak software yang sebenarnya fasilitasi yang sudah memfasilitasi bersama di sini. Next lagi. Nah, ini saya pecah. I spread out. Apa namanya membuka masing-masing.
Kamu bisa habis juga. Ada kok.
Jadi several subcatchment. Jadi udah catchment. Kita pecahin lagi ini subcatchment. Ini udah catchment, kita menjadi lagi pecahin lagi subcatchment. Nah ini menunjukkan masing-masing sungai yang ada di pecahan-pecahan itu. Oke, next. Saya bagilah, kira-kira mendapat luasan areanya masing-masing seperti ini. Kalau ini it show this color show catchment. So green show catchment of bulu kecil.
Orang-orang kaya di sini.
Apa warnanya pink kan?
Ungu,
purple.
Soalnya kayak banyak beasiswa itu yang di luar Jawa.
It show Kumai catchment.
Daerah tiga.
This is Kotawari catchment. Okay. So different catchment
sendiri.
show on those.
Ini kalau beasiswa dari BUMN langsung pergi.
So we have
ya potongan setengah.
Many hydrological station information. Tapi sekali lagi nggak ada yang di sini. Nah ini kadang-kadang kita sering cari apa, nggak ada data di sini. Tapi tetap aja jadi kesulitan kita kurang data, kurang ini. Nah ini poinnya gimana teman-teman bisa memulai step ini. Jadi banyak cara sebenarnya dengan menggunakan engage apa namanya rainfall. Bagaimana mendefinisikan engage rainfall itu nggak ada apa nggak ada data.
Kalau presentasi di sini enaknya pakai bahasa Inggris bahasa Indonesia.
Kami di PUPR
Kalau cara mengajar
saya berpikir simpel dulu, masih simpel sekali. Jadi menggunakan data yang sampel yang ada di
Inggris,
sini,
Inggris.
bagaimana kita interpolasi saja
jadi hybrid setengah-setengah itu.
menjadi bisa digunakan di daerah ini. Next. Ini Dev ya, topografi di mana di atas ini. Resolusinya itu 30 meter. Mungkin teman-teman belum ada yang membayangkan 30 meter di mana, ya kira-kira begini. Kiri kanan itu 30 meter per kotak itu. Jadi kalau kotak ini di zoom, kira-kira begini situasinya. Oke. Oke, next. Nah, ini comparing antara tahun 2017 sampai 2023. Nah, apa namanya? Ini kira-kira perbandingan antara tahun 2017 tahun 2023. Oke, next. Nah, ini perbandingannya untuk masing attachment. Ini juga saya apa namanya, saya bagikan lagi pada masing-masing attachment. Jadi tawar ini pemain dulu kecil, tawar ini pemain dulu kecil. Jadi pengerjaan tiga das tetangga sekaligus bersamaan. Oke, next. Nah, ini perbandingan dari masing-masing dalam bentuk tabel aja ya. Tadi kan angka, ini dalam bentuk tabel saya tunjukkan bahwa, nah ini kalau Prof belum apa urban sama water ini kalau nggak kelihatan di zoom aja ke sini, saya coba zoom ya karena perbandingannya itu terlalu besar di sini. Ini untuk di das bulu kecil, dan bulu kecil ini yang warna hijau ini. Ini kira-kira situasinya seperti ini. Next. Nah ini ini itu elevasi muka air yang ada di laut. Jadi bayangkan ini dari laut, ini dari laut. Nah ini itu adalah muka air yang ada di masing-masing das. Jadi misalnya ini AB, CD, jadi CD. Jadi sepanjang itu kira-kira muka airnya berubah di tiap titik. Karena meternya ini dari 0 sampai 15 kilo, 0 sampai 15 kilo. 0, 15 kilo, 0, 15 kilo, 0, 15 kilo. Ya, mulai. Nah ini kira-kira muka air di apa namanya di sungai, itu. Nah ini band level di masing-masing ini. Misalnya AB, ini biru, ini band level di sungai ini. Nah kalau di sini band levelnya di sini. Jadi kita lihat pengaruhnya dari muka airnya ini. Saya anggap ini kan laut ini, satu laut ini informasi muka airnya sama. Next. Ini cross section we got from the Balai, our branch office in Tirtayasa.
Why?
Kami mendapatkan cross section di titik-titik bawah. Oke, next.
Is it difficult?
Nah, kira di cross sectionnya.
For the next let's prepare.
Ya.
Oke, ini apa namanya, lokasi-lokasi yang menunjukkan sebenarnya tahu Pak mungkin tidak dari yang menunjukkan lokasi. Next. Nah, ini cerita ulang sama dibandingkan operasi bagi. Next. Kira begini, perbandingan rincian kalau ulangnya itu menggunakan data hidrologi yang ada tadi. Ini kalau ulang 2, 5, 10, 25, 50, 100. Kenapa kami selalu menggunakan ini? Karena di dalam peraturan in our regulation of government, Directorate General of Water Resources, we use written period as our baseline. So we still use written period as a baseline for the design plan. Yeah. So ini rainfall pattern at each written period. Yeah. Next. Nah, ini saya menunjukkan beberapa simulatif yang ditunjukkan menggunakan software modeling. Jadi saya tunjukkan simulasi 1, simulasi 2, simulasi 3. Next. Okay. Nah, ini lokasi 1 di sini simulasi 1. As you can see, there is no affected by sea, yeah, and affected by sea. But for the simulated 2, location 2, you can see the discharge from the upstream are affected by sea level. In the location simulated 3, you can see that there is also effect by sea level. But for the high discharge, we cannot see the impact of the sea level. It may because the small the short distance or the small catchment. Ya. Jadi karena catchmentnya kecil, small, pengaruhnya mungkin ketika debitnya tinggi lebih kuat dibandingkan dengan air yang ada di laut. Ini kan tadi ada pengaruh sea level ya. Oke, next. Ini kalau orang tahu, this is the flood map of the 100 written period. Ya, simulasinya. Okay, next. Ini we have a local observation from the people. We do compare with the simulation. Ini we can see still the blank area of the floods observed from the local people, from the local government. But we use another result as the comparison. At this moment, on the Kota Waringin catchment, there is a at this moment, we can use this information on the Kota Waringin catchment as the comparison with the simulation. Nah, kelihatan nih agak cocok ya, agak oke lah buat kita katakan ini terkalibrasi. Karena ini juga dari teman-teman teman-teman balai, teman-teman PU yang ada di Kalimantan. Oke, thanks. Ini kita punya peta dari Sentinel. Ini S1 European Special Agency. Ini ada bulan November 2020, Oktober 2020. Ini juga kita gunakan sebagai komparasi. Next. Nah, ini kelihatan ya kalau ada kejadian banjir di sini, ini simulasi banjirnya juga ada. Dan tapi juga ya, ada juga kejadian banjirnya dan ini juga relatif sama. Gitu. Nah, ini dari satu poin aja, ini bisa kita simpulkan sementara bahwa ini cukup terkalibrasi. Next. Ini juga, ini gambar ini perbandingannya. Ya ada kejadian banjir yang mungkin terbaca di satelit, dan ini relatif yang saya buat-buatkan ini relatif sama dengan yang ada yang kita lakukan operasi ini dengan ulang 25 tahun. Jadi sementara hasil satelit dengan hasil simulasi yang kita gunakan itu relatif sama. Ini juga bagaimana menggambarkan kejadian banjir yang ada. Ini adalah simulasinya. Kira-kira kampung-kampung ini yang mungkin akan berpotensi tergenang gitu. Kampung Lamandau Village, Lamandau Village ini sangat risky terhadap kejadian banjir. Ini simulasi ini menunjukkan bahwa kira-kira daerah inilah yang dimungkinkan terkena banjir. Next. Nah, bagaimana dengan yang lain? Nah, ini jadi apa itu? Mining area. Jadi apa namanya banjir itu cepat located on the mining area. So the mining area also make another problem for the government. So they make a small hole for the water accumulated on those area. Yeah. Next. Ini juga daerah tadi, daerah yang saya bilang dari orang. Nah ini mereka ya banjir, but there is no people stay here. Ya. Tidak ada di situ. Next. Ini beberapa halaman tadi saya sampaikan. Nah ini ada potensi kenaikan yang tinggi ya. Nah ini kira-kira gambaran beberapa tahun kita di PUPR itu as a government we can selected which design we would like to reduce. Misalnya ingin reduce design dengan if we have a big budget we we selected as a 50 years period to reduce. It depends on the because I'm from the government, we consider the money budget for the design. What design? Next. Kira-kira ini pelan di pertawaran ini di pemain itu kalau digabungin budgetnya, ini luasnya, volume-nya, ada peningkatan yang dapat terjadi di sini lah. Dan kita sampai 5 kali, malah dari kalau 20. Nah, if there is increasing from the tourism period to the 10 billion period, it's associated with the money budget. So if you have a money 100 rupiah, it may 500 rupiah. But we have to check it again. I mean, as the imagination, you can see those kind of raising impact to the money budget. Kira begitu. Jadi tergantung yang kita ingin bebaskan atau ingin kita lindungi. Jadi masing-masing area untuk dan pertawar ini kalau nggak salah ini volume area volume sama ini ketiga di masing-masing gas pertawar ini itu kelihatan nggak peningkatan yang terjadi. Ini kecamatan, seluruh kecamatan yang ada di kota Bali ini lumayan begitu. Whole district ya, district. We evaluated district at the risky area to describe the pertolongan bagi lurah-lurah, RT atau bagaimana yang ada di masyarakat. Next. Ini whole district from the lower inundated area to lower to the biggest impacted area by the inundated flood. Nah, jadi kelihatan di kalau 100, next di kalau 40, next lagi kalau ulang 25, next lagi kalau ulang 10, next kalau ulang 5, next lagi ulang 10. Nah, hampir seluruh itu seluruh area tersebut next lagi itu dikuasai oleh Kecamatan Kumai dan Laut Selatan. Jadi at each return period from 100 to 2-year return period, District Kumai and District Laut Selatan is the most affected area always. Yeah. So as a government, we could prepare all major or money budget close to this area. Jadi semua peralatan, banjir dan lain-lain sebagainya itu kita bisa digerakkan kepada daerah-daerah itu. Jadi menurut klasifikasi kesulitan atau klasifikasi berdampak. Next. Ini kalau we have a table for the district table district for to make a simplified how people showing how do people understand which district has the most affected area and the lowest affected area by district. We make a simplified of this. So whole return period is consists of Kumai dan Selatan. Jadi selalu Kumai, Selatan, selalu yang ini sangat rentan. Jadi kalau mau tinggal kira-kira jangan situ, kira-kira ini sebagai bayangan. Ya, atau jangan dekat sendiri. Atau mungkin teman-teman ada yang I don't know, maybe some of these students stay in this area. I don't know. Maybe you can talk much more than me. Dan itu beberapa kali daerah beberapa kota itu menjadi sangat rendah possibility kebanjirannya. Dan ini yang paling rendah dan mungkin jauh dari area bacaan bencana banjir. Ini kita di daerah-daerah. There is Sanda ya, Sanda jadi like Sanda ya. Saya waktu itu di Jepang nggak di Sanda. Ini dari Jepang juga itu yang kepala desa di namanya Sanda. Next. Ini bayangkan nih kalau ini satu potensi banjirnya itu kita untuk taruh 800 tahun. This is for imagination ya. Total flood area is around 16,000 ya. Kilometers square. It's same like the 2.5 times from Jakarta area. Jadi ini banjir yang di Kalimantan itu ada, kalau kumpulin itu area itu bisa 2,5 kali luas Jakarta. Kebanyakan. There is devastation mereka. Next. So, BNPB, National Disaster Agency Planning Agency, have a regulation to classify the risk classification by using a regulation. They have a regulation on this. So we use this classification by DMPP as the picture. Picture. There is a low class, medium class, and high class. Yeah, next. Ini untuk kalau orang 100 tahun, ternyata untuk syarat kota Waringin ini, untuk kelas high-nya itu sangat tinggi. Dan untuk kelas medium dan menurut ini relatif barengan. Untuk yang kelas high ini itu di kota Waringin itu sangat banyak bisa kelihatan. Next. Kalau 50, nah ini juga masih banyak di daerah yang orang Indonesia dan kota Waringin masih banyak daerah bencana yang berklasifikasi dulu. Klasifikasi hard. Next. Nah, untuk kelas kalau ulang 10 tahun, jadi kelas kota Waringin dan Akupai ini itu relatif sama, jadi belakangnya jangan jauh. Jadi untuk kelas medium itu relatif sama. Jadi malah kelas low itu lebih banyak dibandingkan dengan kelas medium dan kelas high. Itu buat tahun. Next. Itu yang di kalau 2 tahun ini hampir bencana di gas hulu kecil itu hampir
Bisa berapa slide ya punya bapaknya?
Memang
Nggak kelihatan ya?
Mereka bisa pegang, bisa dikatakan juga hampir tidak ada bencana itu. Padahal banjir ada, tapi klasifikasinya menunjukkan bahwa hampir tidak ada untuk kalau 2 tahun. Next. Nah, ini tadi saya bilang. There is potential. There is no potential for flooding. Hulu kecil catchment. From whole classification from PUPR. From PUPR classes. Di gambar A itu kelihatan bahwa kalau yang A ini but that nanti potensial banjir kecil. Jadi every catchment has a small potential flood, low potential flood at each written variance of flood simulation. But there is no potential on medium and high classification by BNPB in the Hulu Kecil catchment. Okay, next. Saya pikir ini tadi sudah saya sampaikan juga. Saya pikir itu saja dari saya. Lebih dari kurang mohon maaf, saya kembalikan kepada Ludwig ke moderator. Terima kasih. I'm sorry, I have a question for Idham-san. Simple question. Why don't we basin you selected for the hazard map?
Saya
Ya, stop sharing dulu.
udah stop share.
Biar bisa
Oh,
spot.
sorry.
Iya, iya, gak bisa. Gak bisa.
Ngapain?
Bisa gitu, nggak bisa kan yang di share di sini. Nggak bisa. Nggak bisa.
Southern part of
Oh, di sini yang enak. Kan yang di share di sini.
is the smallest compared to the others. So
Kalau mau
I guess
ini yang ke
this
situ
is
bisa.
the-
Ah,
as example for the student how to utilize
ini punya saya kan?
the limited analytical data
Itu saya share dulu.
for them to say to not to avoid the way to show the data to make
Ini
it
sharing. Stop sharing.
Stop sharing.
All right, is there any more questions?
Ini biar gak ada perfectnya nggak bisa. Jadi biar kayak
Kalian ngobrol masuk.
Thank you. I would like to Dr. Koyama. Yeah. In your research, you use methodological to estimate the release rate for is there any consideration about the lag time from rainfall until the peak into the last into the dam in your research? So you also consider about the lag time peak with the time of peak from rainfall occur until reach to the dam. You consider about it.
how you use about the rainfall to the rainfall.
Because in your
Lari.
in your equation because you put ER equal to E in plus something about rainfall and then time.
Yeah.
But I'm not sure about the did you consider about the large of or the area of river basin because the larger river basin we have a lot of time to make a like decision to
Yes.
to the pre-release. But how about for the like small river basin?
Yeah, so in Japan, the basin is not big. For under my tidal basin in central region, not big. So stream basin area is about 300 kilometers, square kilometers. If the more big basin, our method for apply the more big basin. So maybe the river length is long. So maybe the install the river water level station point to the river, so we can apply the more big and big, I think.
All right, is there any more questions?
I have one question for Mr. Idham. Actually, currently I am working on flood assessment in Indonesia capital in Nusantara, and I have bigger problem because I could not get the data for river cross-section. I already asked the BWF, wilayah 4 Samarinda about the data, but they only have only 3 branches of the main river in Patu River. So you said that you have many data in Southeast Asia of Kalimantan, so I think can we make a collaboration to build a model. Thank you so much. So there is two explanation for this. First, we conduct the local observation for the conception. So yes, you can see the point location of the profession is not so much. Only small location. So it's connected to our budget. So we have small points. For the local observation. That's great. There is a great equation to show the fact protection for the model. So you can see our picture, our paper with the Professor Kure. So using those, maybe you can use how to develop, how to construct the protection or using the equation. So the third way, I think you can use the but this is old way, technical way. And maybe many researchers and many paper already explain how to use it. And yeah. And also now in the especially in the PUPR, already many departments already completely by using LiDAR. So they are now using LiDAR to how to capture river wind and clean river. I think there is a difficulty to capture that but still the subtraction directly to the field it's possible. Still used in the event. So you can ask them or you can just find data. Actually, this is not in the time, not in the Ibu Kota, in the capital city. This is the very part of the capital city. Therefore, for the calibration, yeah, of course, you can do that.
All right, I fear we only have time for 3 questions for the Q&A, so we're gonna close this Q&A session and we'll move on to the next agenda. For the next agenda, there will be a little speech that I think a lot of students, especially Pertamina University students, will find interesting, which is about how to go to Japan to study. That will be delivered by Mr. Akbar Rizaldi and Indra Aditya all the way from Toyama Prefectural University in Japan. To Mr. Akbar and Indra, the stage is yours.
Everyone. Selamat siang. My name is Gede Aditya and I am a first year master course student at the Prefectural University. Sebelumnya
kita enaknya pakai bahasa Indonesia atau bahasa Inggris? Berapa orang yang punya bahasa Indonesia secara ASN? Yang bahasa Inggris? Oke, kayaknya banyak yang bahasa Indonesia karena mungkin banyak yang penasaran. Oke, kita mulai aja. Perkenalan dulu.
Ya, perkenalkan saya Akbar Rizaldi. Saya saat ini mengambil program doktoral di Toyama Prefectural University, juga mahasiswa bimbingannya dari Kure Sensei. Mungkin itu aja singkat dari saya. Mungkin sebenarnya ini merupakan simposium kedua, dan kita pengen share sama teman-teman terkait baiknya gimana supaya bisa kuliah ke Jepang gitu. Nah, daripada banyak melihat presentasi, kita pengennya lebih banyak diskusi, sehingga mungkin nanti presentasinya akan cepat saja. Jadi kenapa sih harus ke Jepang? Karena pertama, world class university education. Jadi sistem pendidikannya sudah baik, kita tahu dari seberapa berkembangnya teknologi di sana, seberapa majunya negara di sana, kemudian high funded research activities. Dengan banyaknya di sana juga riset itu sangat didukung, sehingga beberapa sensei seperti hal ini bahkan untuk kunjungan ke luar negeri untuk memberikan motivasi atau memberikan perkuliahan umum gitu ya terkait riset yang sudah dilakukan, itu juga dibiayai. Nah, seperti itu. Kemudian kenapa lagi? Karena misalkan kalian nih ada yang suka budaya Jepang, nah itu juga menarik bagi saya pribadi, suka atau tidak suka budaya Jepang. Pergi ke luar negeri itu secara tidak langsung kalian akan melihat suatu hal yang baru, hal yang lebih luas daripada apa yang kita lihat selama ini gitu. Mungkin kalian lihat SCBD, ya di sana mungkin kalian juga menemukan hal yang sama, tapi tentu dengan kultur budaya yang berbeda tentunya. Selain itu juga ya, local and global opportunities. Jadi kesempatan untuk kalian berkarir. Jadi misalkan nanti kalian setelah lulus nih, studi apakah S1, S2, S3 di sana, kalian punya kesempatan untuk berkarir yang sangat luas. Karena di sana tuh sistemnya lumayan menarik yang di Indonesia pernah lihat. Jadi di tahun keempat, misalkan 4 tahun kuliah, tahun keempat itu kalian sudah difokuskan untuk magang, di mana magang itu ke perusahaan-perusahaan yang sudah kalian pilih, dan itu mungkin hanya beberapa hari, bahkan hitungannya gitu ya. Terus setelah lulus, nanti kalian tuh udah pasti ke perusahaan yang akan kalian salah satu yang kalian pilih dari magang itu, dan kalian juga sangat difasilitasi sebelum lulus itu sudah ada job fair. Terus kalian apply dan kalian sudah diterima sebelum kalian lulus. Jadi setelah lulus tuh kalian langsung prosesnya adalah penerimaan sebagai pekerja. Adapun hal lainnya adalah karena dengan adanya environment yang cukup global, kalian bisa melihat opportunity tidak cuma di Jepang, tapi juga di negara-negara lainnya. Kemudian broaden network, yaitu sangat jelas karena kalian tidak hanya berkuliah dengan teman-teman di Jepang, tapi juga ada mahasiswa dari negara lain yang juga berkuliah di sana, sehingga kalian punya teman tidak hanya orang Jepang, bisa Amerika atau Vietnam atau misalkan Turki atau apapun. Next. Oke, Indra. Stop. Aja. Ya. Jadi fundingnya biaya ke sekolah ke Jepang itu ada 3 pilihan, private sama scholarship. Private itu kalian bisa pakai yayasan ayah bunda, atau kalian bisa bekerja sendiri di sana. Kemudian scholarship ya tentu biaya hidup semuanya sudah ditanggung oleh lembaga yang memberikan finansial kepada kalian. Nah, eh, private funding ini ya tadi antara orang tua kalian yang biayai atau kalian yang memang udah terakhir sudah kaya gitu, bisa biaya sendiri, atau kalian bisa aja nih ke sana, misalkan kalian untuk apply-nya kalian bayar dulu, terus nanti mengajukan eh, keringanan seperti keringanan seperti yang mungkin kalian juga tahu di Universitas Indonesia seperti apa. Dan itu memang tidak selalu 100%, tapi opsinya disesuaikan dengan kondisi finansial dari mahasiswanya. Seperti itu. Nah, untuk scholarship itu juga cukup banyak. Tapi mungkin di sini kita bakal ngejelasin ada 2 scholarship yang kebetulan saya sama Mas Indra ini beda scholarshipnya. Pertama ini Max. Saya yang mendapatkan Max ini gitu. Max ini adalah kerjasama antara pemerintah Indonesia dengan Jepang dalam bidang budaya, pendidikan, dan lainnya lah ya. Kemudian sebetulnya hal ini bisa kalian dapat nih informasinya di sini di kedutaan Jepang, dan dia buka setiap tahun. Alurnya di situ sudah sangat jelas. Tanggalnya, apa yang kalian butuhkan itu juga sudah sangat jelas sebetulnya. Ini program-programnya dari undergraduate, kalian S1, S2, S3 semua ada, bahkan sekolah vokasi sebagai guru juga ada. Kemudian ini adalah syarat persyarat, kalian juga bisa dapat dari website ini, nanti bisa dicek. Ini aplikasi prosesnya, kalian aplikasi ada tesnya itu seperti tes TPA, matematik dalam bahasa Inggris semuanya gitu, pengetahuan umum. Itu untuk mengecek kemampuan bahasa Inggris kalian dan lainnya. Setelah itu kalian lulus, dapat interview, terus setelah dapat, kalian nanti bisa antara pilihannya adalah kalau kalian sudah dapat universitas, kalian tinggal langsung nunggu keberangkatan. Kalau belum, kalian harus nyari universitasnya. Nanti berangkat, udah deh, sekolah mulai. Nah ini mungkin fasilitasnya, tuition fee itu biaya pendidikan, flight, pulang pergi, awal dan akhir kelulusan. Kemudian kalian bebas mau baik itu tuh kerja di sana sebagai part time atau apapun. Terus ada monthly allowance. Beberapa universitas memang menawarkan student dorm atau asrama. Next. Mas Indra.
Mas, terima kasih Mas Fajar untuk presentasinya. Tadi saya mau mempresentasikan terkait beasiswa saya yang saya dapatkan kali ini. Mungkin case-nya agak sedikit unik dari Max karena beasiswa Toyama Prefectural ini adalah beasiswa dari pemerintah prefecture, atau di Indonesia itu kayak provinsi. Jadi saya dapat beasiswa dari provinsi, dan ada join cooperation dengan sebuah company, dan bukan company yang memberi beasiswa itu adalah sebuah perusahaan konsultan infrastruktur. Jadi dia perusahaan internasional, ada cabang di Jepang dan di Indonesia. Jadi mereka mensupport satu orang mahasiswa di Indonesia untuk belajar di Toyama. Kenapa harus belajar di Toyama? Karena yang beasiswa adalah pemerintah Toyama. Jadi untuk dapat info beasiswanya cukup unik karena kalau kita cari di internet itu cukup sulit untuk mencarinya. Jadi saya kebetulan dapat dari sebuah akun Instagram yang Relocation Indonesia. Ini adalah sebuah lembaga les bahasa Jepang. Jadi mereka punya cabang di Jepang dan di Indonesia, dan mereka nge-share informasi terkait beasiswa ini di Instagram. Dan kebetulan saya dapat dan coba untuk apply. Dan untuk benefitnya kurang lebih sama, cuman ada sebuah tambahan yang cukup menarik, yaitu saya dapat special commuter pass. Jadi untuk transportasi umum seperti tram dan bus itu saya bisa naik gratis setiap hari, setiap waktu selama jam operasi. Terus yang kedua, saya juga disupport untuk belajar bahasa Jepang karena setelah bekerja saya harus bekerja di perusahaan yang memberi beasiswa, Namun baiknya adalah mereka tidak membuat waktu keterikatan berapa lama harus bekerja. Jadi selama saya mau bekerja di sana saya bisa bertahan. Terus ini untuk application prosesnya cukup sederhana, mulai dari apply, terus screening administrasi, terus interview. Interviewnya di interview pakai bahasa Inggris, tapi kalau kesulitan kita bisa menjawab dengan bahasa Indonesia. Tapi waktu saya interview kemarin saya pun pakai bahasa Inggris, saya bisa mengikuti. Yang ketiga langsung berangkat ke Jepang, dan ini durasinya sangat singkat, cuma 4 bulan. Kalau Max itu berapa lama Bang Ibu ini?
Hampir 1 tahun.
Dari proses aplikasi sampai berangkat itu 1 tahun, tapi kalau beasiswa saya cuma 4 bulan. Flightnya Mei, September berangkat. Cukup fast track memang. Sini tanggung jawab sebagai awardee, saya harus membuat report ke pemerintah government-nya, terus ikut kegiatan yang disponsori sama pemerintah provinsi, seperti kegiatan mengenalkan budaya Indonesia ke masyarakat Jepang, dan yang ketiga adalah wajib untuk belajar bahasa Jepang sebenarnya. Dan sebenarnya banyak banget beasiswa yang ada di Jepang itu, seperti ada beasiswa dari kampus, jadi ada MOU antara kampus di Indonesia dan kampus di Jepang, dan kampus di Jepang itu memberi beasiswa kepada mahasiswa dari kampus yang punya MOU. Ya. Jadi sangat banyak sekali. Jadi mungkin kalian bisa tanya ke administrasi kalian, apakah Pertamina University punya MOU ke Universitas Jepang atau lain, bisa kalian pastikan sendiri. Terus ada juga IT Prefectural University Scholarship. Ini sama case-nya dengan beasiswa saya, namun dari prefecture lain di prefecture IT. Terus juga untuk di Jepang tuh banyak hal yang bisa kalian coba, mulai dari part-time job, dan di part-time job itu sendiri banyak banget, mulai dari sebagai clerk di kasir di convenience store, atau jadi penerjemah, atau menjadi guru bahasa Indonesia di sana juga bisa. Mungkin sekian dari kami. Apabila ada pertanyaan silakan, dan kami sangat terbuka untuk diskusi.
Tertarik nggak kira-kira? Atau enggak, lebih suka di Indonesia nih, ya udah nyaman banget. Mungkin ada yang mau nanya terkait apa yang
Selamat siang kakak-kakak. Saya oleh Fatu Zulfa ingin bertanya. Tadi kan ada syaratnya research plan ya. Kita harus buat research plan. Nah, caranya kita tahu lagi ada riset apa di Toyama Prefectural University itu gimana ceknya? Apakah harus kontak profesornya atau di websitenya ada gitu keterangan research yang sedang ada di universitas itu ada apa aja? Itu gimana caranya? Terima kasih.
sorry. Nah, dulu kamu kayak gitu nggak nyari riset sensei gitu?
Enggak, langsung bikin sendiri. Jadi dari pribadi sukanya apa, langsung bikin risetnya. Karena kan riset itu harus dari diri sendiri, karena kita yang ngerjain, kita yang menyelesaikan. Tapi kita juga ya ada case yang lain.
Nah, itu beda banget. Jadi untuk Mas Indra, karena Mas Indra itu memilih universitas itu setelah dapat beasiswa ya Mas.
Iya.
Nah, setelah itu baru dia nyari senseinya. Kalau saya beda, kalau saya langsung nyari senseinya dulu. Sehingga saya browsing tuh universitasnya. Kebetulan memang saya udah kenal dengan Kure Sensei sebelum saya berangkat. Nah, tapi juga saya juga apply ke beberapa universitas. Nah, saya juga cari nih, cari tahu terkait siapa sih sensei yang kira-kira cocok buat jadi supervisor saya nanti. Terus saya cek penelitian terakhirnya berdasarkan apakah Google Scholar terkait research terakhirnya, kemudian ataukah dari si web dari universitasnya. Cuman biasanya web universitas itu agak kurang update, jadi mending dari Google Scholar. Nah, nanti dicek yang terbaru. Kenapa harus dicek yang terbaru? Karena bisa jadi seiring dengan berjalannya waktu, sensei itu interestnya berubah. Sama kayak hal yang terjadi saat sekarang. Misalkan kita awalnya fokusnya adalah di bidang irigasi, tapi dengan adanya perkembangan teknologi ke IoT, jadi lebih ke IoT atau misalkan data analysis gitu kayak gitu. Jadi itu penting banget tuh kalau untuk Max sih. Untuk Max itu, jadi apa yang saya lakukan? Pertama saya cek research historinya dari Sensei. Saya lihat apakah sesuai dengan keinginan saya atau enggak. Kemudian saya bikin research plan, tapi research plan-nya nggak selalu harus sama banget, tapi seenggaknya ada kaitannya. Itu jadinya kemampuan kalian meyakinkan orang sih. Kasarnya mungkin jadi lebih kayak speak aja, gimana kita meluluhkan hati sensei, kayak misalkan kalau oh ya udah oke lah kamu boleh ikut klub saya kayak gitu. Itu terjawab. Ada lagi mungkin? Ini nggak bayar loh kalau nanya. Udah cukup jelas berarti ya. Oke.
Baik, mungkin karena tadi Bapak dan Kak Indra sudah memakai bahasa Indonesia, saya lanjut pakai bahasa Indonesia aja kali ini. Oke, terima kasih kepada Bapak Akbar dan Kak Indra atas paparan materinya. Beri tepuk tangan yang meriah dulu. Saya rasa materi yang tadi disampaikan sangat bermanfaat ya bagi mahasiswa. Mana tahu Bapak dan Kakak ngelihat mahasiswa UPR di Jepang lanjutin S2-nya kali ya, mana tahu ya. Oke, selanjutnya sebelum kita lanjut ke sesi kedua, kita akan ada isoma. Jadi silahkan untuk yang mau sholat, yang mau makan, kita sesi selanjutnya akan dilanjut di jam 1.20.
Satu jam tapi satu.
Udah lihat tursonya nih Banda. Oh iya.
Ladies and gentlemen, now that we're all freshened up, let's move on to the main agenda, that is the second session, which is about tour success of relocation and revival of the capital city in Indonesia. So for that, I would like to invite Dr. Nurul Fajar Januriyadi for his session.
Okay, good afternoon, everyone. Assalamualaikum warahmatullahi wabarakatuh. Thank you for having me here. Okay, I think you already take 2 lines, right? Maybe you have more energy to hear, or I'm not sure. You maybe now is more sleepy. Okay, let's start our presentation. Yeah, today my presentation topic is assessment of future water stress in new capital city of Indonesia under climate change scenarios. This research is, or this topic is one of results of my ongoing research. Yeah, I have another research that this is the result of my my ongoing research. Yeah, before we start this discussion, maybe I would like to share you about my ongoing research. Next, please. Okay. Yeah, My current research is water-related disaster management for whole Indonesia. So I have a dream to make water-related disaster risk management in whole Indonesia. This is my dream, and this is like my contribution for this country. This research there are consists of 3 steps. First one is determining the regional portability. So we want to know which country or which part of Indonesia that has vulnerable to disaster. After that, we do the local scale water related disaster assessment. To more detailed information about the disaster risk in Indonesia, we do some local scale, because in this part, in the first part, we will find the priority, which area has more vulnerability. And finally, we will conduct the water-related disaster risk reduction for whole Indonesia. We will make like early warning system or early warning to the whole Indonesia to know which area will occur the disaster. Next. Okay, let's play the videos. But play. Yeah, this video I already create a program that collect the data automatically from JAXA GSMap. So every 6 hours we get the rainfall videos for Indonesia, for whole Indonesia. And also I already delineate around 8,000 something watershed of basin in Indonesia to know the which area has heavy rainfall and low rainfall, such as this one. This is the situation from in June 2024. So here there is a high rainfall in Penajam Pasir Utara in IKM in New Capital. We convert to this map and we found that this is correlated. Please play the video. The second video. Okay, just click. Just click. Sorry. Just click the block. No. Okay. Click. This. Kayak gini. Okay. Yeah, from BNPB, they find that in Penajam Pasir Utara, they happen flood at the time. So we found that there is a correlation that here if the high rainfall is not so much from this area in Penajam Pasir Utara, but at the time there is a long-term rainfall, more than 18 hours rainfall. So this make this flood in Penajam Pasir Utara. Please next. Okay, that's my ongoing research, and now still do the research because still I need to make more delineation for the river basin. Okay, for today presentation we have some topic. Next. Okay, let's start with introduction. Okay. This figure is from IPCC. IPCC report. IPCC is intergovernment panel climate change. This report show that there is the correlation between the larger or the increase of temperature in the earth to the rainfall distribution. So if we see the picture, this is 1.5 degree increase. So it means 1.5 degree increase is from pre-industrial era, maybe 19 the beginning of 19 until the end of 2100. So totally increase the average of global temperature is 1.5 degrees centimeters. And the second one is 2 degrees and so on, 3 degrees. If we look at the figure, more dark is mean more rainfall. This is the orange. Less more orange is mean less rainfall. It means the climate change can affect to the rainfall distribution. It means there are some area will be got flooded and some area will get drought. So this is the problem of climate change. Sometimes this area is got for example here maybe this area is will be drought and this area is more flood. Okay. And this situation also emphasized by a study in 2013 that the warmer climate is projected to increase extreme rainfall. Increase extreme rainfall in specific area. And one of them is Indonesia. In this research, found that from this research in 2013, almost 60% increase of heavy rainfall in Indonesia. 60% increase. So it means the heavy rainfall or the extreme rainfall will be increased the 60%. So we can find here maybe I'm not sure. Maybe this is like the now situation in our country. Sometimes we got news that some area is got flood, some area got flood, and so on. Maybe this is the reason. Okay, this next. Okay, another thing. Maybe around 3 or 4 years ago, the government decided to relocate capital city. So replacing Jakarta. Now we know that Jakarta is not DKI anymore, but DKJ, Daerah Khusus Jakarta. Yeah. Of course, if there is some policy, should be there is some effect. One of effect of the new capital city is the increase of population in those areas, in that area. The increase population will increase water demand. Yeah, increase population, increase water demand. Okay. And another thing, probably climate change may impact the new capital city water supply because we know that climate change can influence the water distribution. So in this study, examines water supply in the new capital city considering the climate change. Okay. Okay. Let's start with the study sub. Okay, here, this is the new capital city. This is the river basin of Sepaku Dam. So based on the government statement, capital city or Nusantara will be support the water from Sepaku Dam. Yeah. So it will be the distance around 10 or 12 kilometers. Sepaku Dam has area river basin is 200, almost 230 square kilometer. Next, this is the Sepaku Dam, bendungan Sepaku Semoy, not Gemoy ya. Semoy, not Gemoy. Maybe Gemoy is one. This is our friend. Okay, next. This is the land cover in our study site. If we look at here, yeah, this is the capital city. This is from 2013, 17 and 2020. We got the data from Sentinel. Yeah, there is an increase of number land cover, especially in Mihapale. Please next. Next. Yeah, okay. Next. If we look at more detail for the IKN Yeah. So before the government start to relocate the capital city, here still green area. So it means forest. But after government start, maybe 2 years after finish, after they decided to move the capital city, the number of red color, this is built up or urban area increase. This next. So if we look the tail of information here, yeah, this is the number of trees or maybe forest decreased by 8%. This area is, I take the data from radius 2 kilometers from the central of government. And built up area increased around 8,000 something percent. So it's so much increase for the built up area. So this is one of problem probably in the future due to the land cover thing. But I'm not consider in this research or in this presentation about the land cover thing. Next. Okay, next. This is the characteristic rainfall of Spaku Dam and maybe our study site. Here, this is Spaku Dam. For our modeling, we divided the sub-basin into 23 sub-basin. So this is 200 something square kilometer divided into 23 sub-basin. Here, this is the rainfall from 1998 until 2024. And we look at the graph here. The red line is the trend. So within this year, the trend of rainfall in IKN or in our capital city tend to increase. Since we got the data from Jaksa and map here. Next, please. Another thing also, please play the video. This is the temperature, average temperature in our study site. This is got data from era 5 reanalysis data. This is typically same with the previous slide about the rainfall. The monthly temperature tend to increase. Maybe you also feel in our city Jakarta now. Maybe it's like comparing to some maybe some years before, maybe a few years before. Now it's more hot. So probably this is the climate change impact. Okay, next. Okay. Let's start the methodology. I don't put any equation here, so I just put the flowchart. If you want to know the equation, maybe you can ask in the class, yeah? Because most of the you is my student. Okay. The methodology here is start with historical rainfall. Here I use historical rainfall from satellite data from GSMap version 8, and I use here is historical rainfall from era 5 reanalysis data. We make some evaporation analysis. In this case, I use Cradle analysis formula. After that, 23 sub-basin we simulate the rainfall runoff. Each sub-basin, every sub-basin connected one each other. So we use a kinetic wave equation to route the flow. And then finally we calculate the different discharge analysis. Maybe you hear about debit andalan. Debit andalan is dependable discharge. Maybe some of you who take hydrology, maybe you know about this. Yeah, this is the parameter that used for to know the how much water available in some area. Okay. Next step for the climate change impact. For the temperature, I don't use CM. I just use sorry. Okay. sorry. Yeah, I just use forecast by trend analysis. By trend analysis and then make some random sampling to know the fluctuative of the temperature and make like evaporation analysis. For GCM, maybe some of you don't know about GCM, but I will give you some simple definition. GCM is like some country or some maybe some institute of meteorological agency, they make a model. So for maybe for next 100 how's the pattern of rainfall. So we have multiple of model of climate. So this is such as this one for the GCM. So maybe later I will show you the GCM result. And I make the test down scaling. Down scaling is because the GCM is has coarse resolution, and we want to get the local resolution for the our study site. We make some downscaling. We use quantile mapping bias correction. Finally, we do same thing here. Is rainfall runoff subbasin, instant model, and climatic wave, and dependable discharge for the future. And we compare to the water demand, and then we can get the comparison of water stress. Okay. Next. Okay. This data set that we use in this study, we use DEMNAS. DEMNAS is a digital elevation model for Indonesia. This is provided by Indonesian government. Its resolution is 8 meters approximately. For the land cover, I use Sentinel land cover for 2030. DS map version 8 historical rainfall. This is from 1998 until 2023. For the temperature, I use era 5 pre-analysis data 1998 until 2020. This is for GCM. We have 4 GCM here: access CM2, BCC SM2, MR, Myroxic, and MPI SM 12HR with 3 scenarios. For more detail, if you want to ask about this, maybe you can ask my student Abed maybe. Yeah, he already understand about is my student who under me who also work this work this research. Okay, next. Okay, this is the result of downscaling. I just show you one data only. This is from Myroxic. So before we, this is the mean rainfall observation. So this is the rainfall from observation from 1998 until 2014, the end of 14. The total of the average is around 6.644 millimeters. And before after downscaling, we got the value near close to the observation. But before we do the downscaling or maybe bias correction, this is so much different. So it means by bias correction we can correct the how to say the GCM. Okay. Okay, next. Okay. This is the historical chart simulation from influence Putu. This is the start from the beginning of 1998 until 2023. Yeah, you can hear this is the daily data. Daily data. Here is near 2003 maybe, probably the beginning of the end of 2003. This is there are some no rainfall, so that's why the flow will be decreased. decrease in this area, but after that is almost similar, almost more than 5 meter cubic per second. Okay. Okay. If on here, okay. This is the monthly data. Monthly data or monthly historical simulation. If you look at here, the number of dependable discharge is 5.49 cubic meters per second. So, it means if this number is probably is enough for Indonesian for people to for them to provide the water for people. This is the number the line of dependable discharge for 19. For your information, for the water supply in Indonesia, we use dependable discharge 90%, yeah, for Indonesian case. But for the for domestic purpose, but for irrigation, we use 80%. Yeah. Okay, next. This is monthly dependable discharge for Spakudem. Okay, next. Okay, this is our simulation for the projected inflow in Spakudem. If we look at this picture, for the low discharge is almost similar with the historical. Yeah, for the low discharge is almost similar to historical, but for the high discharge is much higher, comparing much higher. It means that the rainfall due to the rainfall in Spaku or in IKN is more higher, much higher comparing to the historical. It means this area is tend to get flat comparing drought. Yeah. So based on this result, we can say that IKN more prone to flood comparing to drought. Okay. Yeah, this is we can say significantly increase for the maximum. This is maybe the maximum here is 20, is around 80, so 4 times higher compared to current situation. Next. Okay. This is the result of dependable discharge for each model. Here we have SSP 1.6 and so on. This is the model. There are 12 data sets. If we look at this result, most of DCM or the future of discharge in IKN stay higher compared to the current situation. We in the current situation is around 5.5 cubic meter per second, but here is most of them is more than 5.5. Maybe there are some DCM show that less than the dependable discharge for the historical. Yeah, this data is the end of centuries. So I simulate this data until 2075 until 2100. Yeah. So I'm not sure. Maybe most of us will be die at the time, but yeah, this is the situation. If we still alive, so maybe this confirm is correct or not, right? If we alive. Okay, next. Okay, this is the if we call it the water demand is the government said that the total population of IKN or our capital will be 2 million people. Will be 2 million people with average demand is 150 liters per person. So approximately we need to 3.5 meter cubic per second. So if we compare to this data, so I can say that using this data, we can say that the water supply will be enough in the future. But another thing is the problem is a flood problem in IKN. Okay. My conclusion. I think this slide is the most weight for you, right? Because the previous slide is so much boring. Because this is the last one. Okay. We find that the analysis result indicate the climate change does not affect to the water supply fulfillment in the new capital, as the water demand remain lower than reliable discharge or dependable discharge for each scenario. Yeah. The first conclusion is the water demand is much lower compared to the water supply in the future. In case climate change, yeah. This not include the change of land use and cover change, right? Okay. And the finding of the study also that new capital is more prone to flooding rather than drought. Okay. So this is maybe the conclusion. I thought maybe if you have some question, you can ask. Thank you.
Okay, everyone, is there any questions?
Thank you for your presentation. To page before. Yes. So this, I understand the water stress in the line over the so satisfy the water supply the amount of water. So what this is average in month or year?
In this month.
Month. Also the future data, I think is much more occur the flood is I understand, but the drought period is so the period of rainfall period or drought, no rain period is poor.
Yeah, I understand.
Yeah.
Yeah. So maybe you said that the no rain.
My question is that if you evaluate the monthly data, it is enough to the time scale.
Okay. The slide. Yeah, you're right. So if you look, this is the simulation from the beginning of 1998 until 2100. So maybe there is some part, let's say the orange one, there are small rainfall, but still, even though it's small, it's covered by the previous rainfall. So because so much high. So fortunately, we have them in this area, so we can control the outflow from the dam. So this is maybe some good advantage for this IKN.
Yeah, I understand. Thank you very much.
Yeah.
Okay, does anyone have any more questions?
Okay, thank you very much, Dr. Fajar, for I think very important presentation.
related to the Indonesian new national capital city. Yeah, could you show the slide for the conclusion? Yeah, I think this conclusion number 2 and number 3 are very important to us regarding the development of new capital. And in the conclusion number 2, it is said that water availability in new capital has no problem to fulfill the demand in the future. Yeah, considering land cover change. And also point number 3 is important because it is said that yeah, the problem is more in the flood problem. So yeah, as you mentioned before, you use dependable flow for 90% probability, and yeah, that is very interesting. But did you have flow duration curve for, because yeah, maybe to confirm the point number 3, because if we have the flow duration curve, so that we can analyze the not only low flow but also average flow and high flow, and then we can compare the existing value with the projection in the future. I think that's all. Thank you very much.
Yes, thank you. I think it's a good idea. Yeah, we can we can make the low duration curve in next week. Thank you for your suggestion.
Does anyone have any more questions?
Thank you, Mr. Fajar. Your presentation is very great because we share the same study area. My question is about your historical flow simulation. Yeah. Did you do calibration correct the result with the existing and the actual value of discharge? Because I think that is the most important in modeling. Thank you so much.
Yeah, you're right. Yeah. For this presentation, I did not do any calibration. Yes, we don't have any data on it. But for this presentation, I would like to show the comparison only for the future and the current situation. Yes, the current situation need to improve because yeah, we don't have enough data. Maybe next time we can ask to Dr. Idham to get the data. Maybe we will better simulation. Yes.
Yeah. Dr. Fajar, it's interesting your presentation. Actually, I would like to ask your opinion about when we think about the future condition that you did the statistical bias correction, right? So actually, we couldn't predict the future condition. It could be change the statistical condition. So, do you think to do the further research to do the dynamical downscaling to see the proportion and distribution, spatial and temporal condition of rainfall based on dynamic condition? Since some researchers also avoiding for statistical downscaling because in reality, maybe statistic may change in future. Thank you.
Yeah. Okay. Yes. Interesting. Yeah. Yeah. Current. Yeah. So current research also do dynamically downscaling. Dynamic downscaling. However, okay. For this, sometimes the dynamically downscaling also need to that we like do but for the future also we need some parameter, right? For more, how about the parameter to make sure this parameter will happen? So this is also another thing. And another thing also, by using dynamical downscaling, still you need to make some bias correction because all happen So this, yeah, we can say the future is not, we can not sure which one is right. But for the statistical downscaling, maybe it's more easy, the most easy way to find the to bias correction. But yeah, if you can do the like dynamical downscaling, is need also more costs, right? Because you need supercomputer, right, to do that. So yeah, maybe currently this method most effective for us, like Indonesian people. But I'm not sure for the developed countries. Maybe they have more sophisticated technology, so they can find the dynamical like. Ya, the last one. Siapa yang menanya? Baik.
The discussion.
Okay. Beforehand, can I use English Indonesian language?
Ya.
Sebelumnya kan tadi Bapak sempat menyinggung tentang tank model. Kebetulan kan saya mengambil capstone perencanaan bendungan Pak di Bendungan Sinar. Nah, di dalam perhitungan tank model kan itu ada beberapa parameter. Sepertinya itu datangnya dari mana dan cara mendapatkannya juga dari mana Pak? Seperti kondisi yang tinggal di dalam tank dan tinggi air dari dasar sampai ke outlet tanknya itu Pak. Kalau boleh tahu Pak sih cara dapat itu dari mana ya Pak? Terima kasih.
Ya, sebenarnya itu pakai bahasa Indonesia juga ya?
Boleh Pak.
Oke, sebenarnya itu sama kayak pertanyaan sebelumnya, itu harus dikalibrasi dulu untuk mendapatkan parameter-parameter tersebut ya. Jadi tidak semata-mata langsung di. Nah, dalam konteks ini saya menggunakan beberapa pendekatan saja sih. Pakai tutupan lahan sekian, itu seperti apa dan seterusnya. Tapi pada intinya kalau mau buat model seperti itu harus dikalibrasi untuk menentukan parameter. Coba-coba, oke? Ya, nanti lebih detailnya di ruangan kan kamu ini saya juga ya. Oke. Ada lagi? Tadi satu lagi. Satu lagi. Bimbingan
Tes.
Ya,
So first of all, I'm sorry if my questions probably will be one of the easiest questions that will be answered. So my question is because based on your answer to Dr. Before the first questions, you said that if you want to check the inflow, you check it based on the dam. What if you want to check something but there's no dam in it, and how you check the inflow?
Yeah. How to check the inflow without dam? Yeah. We can make like we can put the we call it water level record.
Kami mau nambahin kan sini discussion paling terakhir.
Discharge flow.
Mau dikasih ada beberapa materi yang ingin disampaikan.
Yeah, maybe later in hydrologic
kan
class you can find
sesi yang terakhir discussionnya setengah jam.
You can know this.
Itu sesi kami ada yang mau disampaikan terkait discussion.
How to
Tadi
measure
discussion berterarah gitu.
It's easy. Yeah.
Thank you for the answer.
Itu paling terakhir.
Paling terakhir.
Well, thank you to Dr. Nurul Fajar Januriyadi for his presentation. Before going on to the next session, we have a little intermezzo. So we will give souvenirs plaques for Dr. Naoki Koyama and Dr. Idham Riyando.
The one and only you. I will prepare your presentation.
Please give a round of applause, everyone. Next will be for Dr. Idham Riyando. Give applause, everyone. The next presentation will be from Mr. Akbar Rizaldi from Toyama Prefectural University in Japan.
Okay, thank you for the time. Can I?
Yes, you can use. Yes, please try for that.
Yeah, thank you. So, good afternoon, everyone. Are you still into the screen or somewhere your mind?
Yeah.
Yeah. I would like to present actually this research based on my latest paper. Actually, it's also part of your teacher research. He helped me, and I just add some little adjustment. Then we published the paper. So the title is Toward Sustainable Flood Resilience: Assessing Efficacy of Paddy Field Dams to Reduce Floods in Jakarta. So this is the content. The content is quite simple, but let's see the inside. Okay. Background. So when had it started? Actually, flood in Jakarta already started long time ago, before our independence day. Okay. So if you asking about why Jakarta always flooded, actually before it was Jakarta, but Batavia is already flooded, and it exacerbated it getting worse by rapid urbanization, city development, land subsidence, and societal driven flood problem. And this is the documentation of all this Jakarta flood. And this is the driven factor. So land use change, you can see this is the change of land cover. The right one is the built up area in 2002. We almost all Jakarta already covered by built area. And this is the land subsidence. We also knew that overgrown groundwater extracting could affect the land's condition and make a land subsidence. The red one is the worst condition of land subsidence. It's located in North Jakarta. And other problem is flow capacity reduction. It could be by waste clogging, sedimentation, illegal housing, or any problem. And also Jakarta, because the Jakarta already covered by built up, and also it's already mentioned by your teacher, Dr. Fajar. the heat island effect also applied to Jakarta because the built-up area could amplify the temperature at the surface. The effect of increase of temperature also increase the capacity of atmosphere to holding the water vapor. So increasing one degree Celsius rise in air temperature could increase the water holding capacity by around 7%. It means that's why your teacher said that in the future the probability of high rainfall will increase because the water holding capacity in future also increase due to the high temperature. So the effect of land use and climate change on rainfall and discharge, we can see that based on several scenarios of RCP and SSP, the peak discharge at several locations like Manggarai, Depok, and Katulampa also increase in the future. And also the high rainfall also increase based on the future scenarios. And this is the timeline Jakarta's flood studies. So actually Jakarta already have done several study around about the how to manage the flood since 1973 until 2013, the NCICD. But yeah, still we still heard the news that Jakarta still flooded. And also flood Jakarta with countermeasure. Several countermeasure already built in to avoid to reduce the flood condition like Banjir Kanal Barat, Cengkareng Drain, also the dredging in Ciliwung, Banjir Kanal Timur, canalization Ciliwung River. So this is Padi filter, the new innovation, and it's quite famous in Japan now. So they try to use the paddy field area as the temporary water pond for flood, so we can reduce the peak flow of rainfall to avoid to reduce the flood condition. So the trick is we put one equipment to control the outflow of the rice field area. Then the flow, the water flowing to the river will be reduced. That is how we reduce the peak flow for the river by paddy field area. This is the equation we use in our research. So we also apply the future climate and land use scenario. We use the worst condition as SP3 when the Jakarta already covered by built up area. And also we apply the RCP 8.5 for the future climate condition. And we apply 8 global climate model under scenario 2.6, 4.5, 8.5. This is 8 model of global climate. And this is the flood inundation model. So it contains 3 modules. So this is the rainfall runoff developed by Kure Sensei. And we do the 1-dimensional and 2-dimensional simulation by using numerical simulation. And it's already calibrated by Dr. Idham in 2013. And it showed good result. And we use this model to check the efficacy of the countermeasure for flood in future condition. And after that, we want to see the impact on the financial condition by using expected annual damage cost and benefit cost ratio. We also using this one that already developed by Dr. Fajar. So this is several structural countermeasures that we want to compare with paddy field dam by increasing the river levee, and dredging the river bed, and also widening the river width, and put some river pond at several main river in Ciliwung Basin. This is the result. So this is countermeasure 1 when we increasing the level of river levee. This is the countermeasure 2. We increasing the river levee and dredging. This is the countermeasure 3 by widening the river. This is countermeasure 4 by putting the for in river pond, and this paddy field dam for countermeasure 5, and countermeasure 6 is using paddy field dam, but we increase the area of paddy field dam in this basin. So we try to compare this figure show the comparison between the application of countermeasure with the original flood condition. We can see the red area show that the water level of flood is increasing, and the blue one is water level of flood is decreasing. We can see that the countermeasure 5 and 6 by applying paddy field dam could decreasing all the flooded inundated area water level. And while other countermeasure, several area experience increasing in water level. This is the inundation area. This is the inundation volume and the percent of volume reduced. And we can get that the countermeasure 2 is the higher percent of volume reduced for flood. And it's followed by converting the several cropland to paddy field dam to increase the efficacy of paddy field dam, then so on. Then this is the damage cost estimation, for example. So damage cost estimation is we calculate the how much damage cost that should be experienced when the flood occurred. So we need the land use condition, flood inundation map, and several equation, and we calculate. We got damage cost. And this is benefit cost calculation. So to compute the benefit, we use the original. We calculate the damage cost of original. Then to see the benefit, we compare to the damage cost when we apply the countermeasure. So the difference between the damage cost is the benefit that we can conserve. And for the compute for the cost variable, we calculate based on several research, and we got this result. So, and then we calculate the BYC ratio. And for paddy field dam, we also using several research to calculate the benefit and cost of paddy field dam, and this is the result. Then we compare with the countermeasure 2. It shows that the countermeasure 2 structural has low benefit cost but high PAEC. Then also we try to compare with Dr. Fajar previous research to see the efficacy of paddy field dam with other countermeasure, and we got this result. The difference, this is the without countermeasures, and this is with all the countermeasures. We can see that still the countermeasures that conducted by Dr. Fajar still has the high damage reduced, like recharge and retention pond. And it's followed by countermeasure 2 by increasing the river levy and also dredging the river to increase the water capacity of river. Then it's followed by increasing paddy field dam area. So based on this one, we can see that paddy field dam also has a promising result. So in conclusion, our findings reveal that all adaptation measures has discernible impact on reducing flood risk. Raising embankment height by 1 meter and dredging the riverbed into depth 1 meter is mostly effective adaptation measures. The implementation of paddy field dams to reduce flood risk in Jakarta is the least effective due to the limited rice field area. Increasing rice field area could significantly enhance its effectiveness, and the BYC value of paddy field signifying its economical viability despite changing cropland into paddy fields. So my suggestion is from this research, this research highlight the importance of considering integration of structural and non-structural countermeasures in flood mitigation efforts. The combination of adaptation measures may increase the flood reduction impact and also economic viability. Further study is needed to see the most efficient combination between all the adaptation measures. The study shows also the potential of paddy field dams flood adaptation measures in Indonesia. Furthermore, a comprehensive benefit cost analysis may increase the feasibility value. That's all for me. Thank you for your attention.
Okay, we're going to open a Q&A session for only 2 questions. So if anyone wants to ask Mr. Akbar, please go ahead. Bahasa Indonesia juga nggak apa-apa.
Thank you for your question. I would like to ask about how did you apply the paddy field dam in your model? Because you mentioned that you have rainfall runoff model and then you have a flood inundation model. Which part did you use the paddy field and how did you do it?
Okay, thank you for your question. Actually, yeah, I think I forgot also to explain that how I simulate the paddy field dam. Actually, the paddy field dam I already mentioned that we use this equation. So this equation we apply into numerical simulation based on the sub-basin. Then for paddy field land cover sub-basin, so we divide one sub-basin into several land cover categories. And for paddy field dam, we calculate based on this one, and other land cover, we use the normal model from Kure Sensei. So after that, we multiply all the land cover runoff, then simulate it into the flood inundation model.
Does anyone else wants to ask a question?
Okay. Okay, thank you very much, Mr. Akbar, for very interesting presentation about the flood countermeasure in Jakarta. Okay. Could you show the last slides about the recommendation? Okay, this one. Yeah, the last point is very interesting because you also already conducted the benefit cost analysis in the study, and then you mentioned about the suggestion to do the more comprehensive benefit cost analysis that can increase the feasibility value. Do you have any idea what kind of detail or comprehensive benefit cost analysis that is needed to do in the future, comparing to what you already conducted? Yeah, thank you, Dr. Farid, for your question. Actually, this point comes because I already conduct this research based on the assumption. The assumption I got from a researcher in Japan. So the Japan condition I applied for here. So it could be different with the Indonesian conditions, like how much money that the government have to prepare for for the farmer who use this paddy field dam for flood reduction. So I think like a political, social, cultural condition, and also the structure of paddy field area or paddy field structure is different. In Japan, several paddy field or perimeter is built based on concrete. In Indonesia, almost all the rice field based on the earth, right? So the height of the water could be stored in the paddy field. It could be different. How much money that government has to prepare for the farmer also different yearly, and also how much cost that we need to increase the capacity of the paddy field also could be affect the benefit cost condition. That's what I mean by comprehensive benefit cost analysis, because all I did still assume based on the Japan condition.
Okay, we're gonna close the Q&A session. Thank you to Mr. Akbar Rizaldi for your very informative answer. Okay, before continuing on the last speaker, I have a little icebreaker to test your voice. So I would like everyone in the audience to participate. This icebreaker is called clap. So basically, when I say cherry, everyone will clap once. When I say apple, everyone will clap twice. And when I say orange, everyone will half clap. Does anyone know how to half clap? Someone in the audience? Maybe? Okay, this is how you half clap. So you basically don't clap. So yeah, half clap. Okay, so everyone's ready? Okay, let's start. Apple, cherry, apple, cherry, cherry, orange. Some of you got it wrong. Okay, let's start again. Cherry, apple, cherry, orange. Okay, one last time. Orange. The first one. Okay, we're gonna do it one last time. Apple, orange. Okay. Now we're gonna continue on the last speaker of this session, Mr. Indra Aditya from Toyama Prefectural University in Japan.
Good afternoon, everyone. Thank you for being here today. Thank you for accepting us. My name is Gede Indra. I am master course student at Toyama Prefectural University. And for your information, I am from Lampung. And for today's discussion, I have already prepared a discussion with the topic of assessing climate and hydrological condition of Indonesia's new capital city by integrating future climate projection, land use change, and GIS-based analysis. Okay, here is the content for today. First, we will briefly overview about Indonesia's new capital city project. I believe that all of us here already knew that Indonesia is moving its capital city from Jakarta to East Kalimantan. There are several reasons why Indonesian government needs to move the capital to East Kalimantan. The first reason that we got from the information spreading on the internet is traffic congestion station in Jakarta. According to TomTom.com, a company that helps navigation technology and mapping products, they said that Jakarta is ranked 13th of time travel distance. It took about 23 minutes 20 seconds for people in Jakarta for driving in 10-kilometer distance. And people in Jakarta, in average, in 1 year, they spend about 225 hours in a year for driving. And more than half of that is spent by traffic congestion. The next reason is population density. According to Central Bureau of Statistics of Indonesia's data in 2023, in their data, they said that people who living in Jakarta, more than 10 million people, that make Jakarta is one of the most populated cities in the world. The third reason is economic concentration. According to the same organization, Central Bureau of Statistics, they said that Jakarta is contributing on 17 to 18% of Indonesian total GDP in 2023. And we knew that Indonesia has 38 provinces, which means the other province only contribute in average about 2.2%, which means Jakarta is contributing more than 9 times higher than another province in Indonesia. The last but not least reason is flood-prone situation. According to the news that's spreading on the internet, within this year, 2024, about 4 flood events has been recorded. The first event happened on February 2nd, 2024, and the last one happened on July 6th, 2024. I'm sorry if this data is not updated, because I don't live in Jakarta currently. And furthermore, some part of Jakarta, like in Jakarta, North Jakarta, the elevation is lower than sea level, which put Jakarta in dangerous situation for sinking. And moreover, it could be exacerbated by sea level rise condition due to global climate warming. Then Indonesian government decided to move the capital city, and the plan has been built since 2020. Yeah. There are several reasons, according to ITN.go.id, a website that organized by Indonesian government. They said that there are several reasons why East Kalimantan has been selected for the new capital city area. The first reason is high accessibility, available necessary infrastructure such as Balikpapan Samarinda Highway and Trans Kalimantan, having wide area that only covered by productive and agricultural forests, having airport and harbor strategic defense area because it could be protected by Navy, Army, and Air Force. It's also located near Makassar Strait. They make it a strategic place for trade ship trade. And also the East Kalimantan is considered having abundant water resource. And because of this reason, Indonesian government decided to move the capital city to East Kalimantan. But even though the new place having many advantage features, it could not guarantee that the new place will be safe for natural disaster. And because of that, we need to assess and evaluate the future condition, especially for flood, that probably could happen in the future in the new capital city of Indonesia. Now we are on the early stage in 2024, and the full construction is expected will finish completely in 2045. And according to their data also, the new capital city will cover about 56,000 hectares. Now we add a new boundary here named Sangay watershed. Within this Sangay watershed, there are several rivers flowing to the Paku River, the main river here. And then the blue polygon representing the central of new capital city where the construction is doing now. And we take a look at the characteristic of topography river in Sangay watershed, and we could see that most part of the river is having low slope, but when it moves to the upstream area, it has considerably high slope value. And also we collected data from Global Hydrologic Soil Groups, HYSOGS, a data that published by NASA department, and this data is suitable for soil curve number runoff based analysis. And they provide data for all the entire land or in the world with 250 times 250 resolution. And we could see that in the middle of Sangay watershed boundary, the soil characteristic is considered to have moderate to high runoff potential that could make this area is prone to be flood, but we need to check by further analysis. And then we got news that's spreading on the internet currently. Within this year, in Monday, 24 June 2024, a flood has been recorded, and then it recorded again on Monday, 13 September 2024. And before 2024, about 6 flood events also was recorded. In order to maintain and keep the water supply for people who will live in the new capital city, Indonesian government already constructed several infrastructure such as Paku Semoy Dam that already integrated, I think about some time ago. And then currently we are constructing Paku Dam intake, and this infrastructure also considered to help to reduce the flood risk that could be happen in the new capital city in the future. Next, we will discuss about land use and land cover analysis in the new capital city. This is the land use and land cover map that we got from GLAD, Global Land Analysis and Discovery. They create this data by using advanced satellite technology and using machine learning for classification imagery. This is data from 2010. Actually, they provide from 2000 until 2020. And you could see that the growth of built-up area is an area that a cover area that the cover already changed by human activity. It doesn't change pretty much until 2020. And then we updated the data by using digitation step. And we could see that the build-up area is increasing dramatically by that represented by red pixel. Then we conduct future land use and cover map projection by using ENN, annual artificial neural network. and we included several raster as input, such as dam, distance from new capital city, from Nusantara, slope, distance from river, and distance from road. And from this analysis, we could get future land use map in 2031, 39, 47, and 55. And here is the result. This is the result for 2039, 31. And we could see that if we compare by the previous image, the red pixel or the built up area is increasing, and it keep increasing until the last year, 2050, and probably will keep increasing if we extend until 2000, until several years in the future. And here's the statistic. We could see that the area of built up is increasing dramatically, and as a result, forest area and water body area is increasing. And this is the reason for validation, because we need to validate our model before we continue for the projection. Next, we will discuss about spatial temporal precipitation analysis. We collected 5 different climate scenarios from 6 different models. We got this data from Copernicus.com, website that provide global climate data, and we could access it freely because there is an open data. And then we conduct statistical downscaling by using 2 different data, quantile mapping and quantile delta mapping. But unfortunately, we only put statistically downscaled by 1 station, because BMKG or Meteorological, Climatological, Geophysical Agency only have 1 station near our new capital city. And we also compare the result by using frequency analysis method. And here is the result. If we use quantum mapping, the result from frequency analysis is higher in the all over return period until 70 years. Here, why only 70 years? Because the Copernicus only provide future climate projection until 2100, and I want to make an apple-to-apple comparison here. That's why I only limited to 75 years. But for the next year, for the next step, I would like to extend until several hundred years in the future. And when we use quantile delta mapping here, we could see that when we take a look to the small value of return period, the result for frequency analysis is higher than quantum delta mapping. But when we look at the higher return period, especially starting for 75 years, the result from quantum delta mapping is higher than the result from frequency analysis. And then this is the accumulative of future climate projection by using 6 different models. And you could see that the total runoff is increasing. Next, we will conduct the water availability analysis by using GIS-based method. And this is the workflow. We are using several raster input like raster dam, GLAD, drone station rainfall data, and CHIRPS. CHIRPS is a previous data that provide precipitation spatial distribution of 5.5 pixels in all area in the world, starting from 1980 until 2024. Then they still keep updating the data. And then we calibrate by using ground station rainfall data to keep and to ensure that the value is matched with the actual measurement. And then we are using ministerial regulation to get the weighted value base. And then we use raster calculation to get the water availability map. This is the step of how we calibrate the CHIRPS data, and then this is the result, the spatial distribution of precipitation, and this pixel resolution is about 5 5.5 kilometer square. 5.5 kilometer times 5.5 kilometer. This is how we conduct the raster calculation. We use this value, and every single raster has their own value, and every own value have their own weighted value. And here is the result. We could see that within this water set, the water availability is considered high to really high. So we have a high resolution water, a high resilience water availability area. But the next question is, what would happen if we have too much water? And we also try to project the future condition by using raster value, the raster result from land use and land cover, and then the value from statistical downscaling. And here is the result. We are using the lowest or the minimum value, the minimum average total rainfall per year of the result to create a new water availability map. Even though we use the minimum total rainfall, this area still considered high to really high water availability area. But the really high pixel that depicted by dark blue is decreasing. And then we are doing flood hazard analysis by using GIS-based map. And here is the workflow. The workflow is similar with the previous one, but we are using different input with different weight value. For the input, we use full accumulation, river streamline, elevation map, slope map, LULC, soil map, and average annual rainfall. And we are using AHP, analytical hierarchy process, to get the value of each raster. Then we multiply the value of each raster by its corresponding weighted value to create the new raster. And this is the value. And this is the result. By using historical rainfall and the current land use land cover map, we could see that the area of new capital city in this area is considered having moderate risk of flood. Then we try to project a future condition by using statistical downscaling result and then future land use land cover map. And we could see that the risk, the hazard level of flood within this area is increasing because the red pixel is increasing in this area. I want to acknowledge that this is only a linear model, so it could not involve the physical process of how flood happens, how water is flowing. So this analysis method cannot do that. And then for further analysis, for the next step or the next activity that we want to do is incorporating and doing hydrological and hydrodynamic models to calibrate and check this value. And then we write in the conclusion. First, Sunday water set where the new capital city is built, we experience rapid growth of urban areas. And then for the second, under the current condition of LULC and historically recorded rainfall data, Sunday water set is considered as a high resolution water availability area. And then, under the current condition of LULC and historically recorded rainfall data, the vast majority of areas in Sunday water set have a moderate level of flood risk, and the risk, the hazard level is increasing in the future. But we still need to do the hydrological and hydrodynamic model. And this study contributes to the preliminary analysis of water availability and flood hazard analysis in Sungai River, especially in the Nusantara. And for the next step that we need to do and we need to think is we need to get data for river geometry and hydrologic measurement, because when we try to get data from BWS, they only have many small data. They only have 3 branches of the river within this area, and then we need observation, the actual observation in this area. And then we need river discharge observation, more comprehensive disaster simulation, especially for flood, for erosion, landslide, sea level rise, or even tsunami, because this area will be so important, will be so much important for us in future. And then we need to evaluate the adaptation measure towards its disaster possibility. That's all from me. Thank you for your kind attention.
We're gonna open a Q&A session for only one question because our time is limited, unfortunately. So does anyone wants to ask a question?
Bahasa Indonesia aja. Itu kan di capital city tuh. Tadi Mas sudah memproyeksikan bagaimana kira-kira ke depan Indonesia bagaimana. Pertanyaan saya, ini seberapa yakin memang bakal begini gitu? Karena apa namanya, ini kan ngomong soal pembangunan, apakah pembangunan di city yang sekarang ini bisa betul-betul men-trigger seperti yang digambarkan? Itu gimana cara meyakini keyakinan Mas sendiri atau modelnya sendiri mana? I'm asking about the confidence of the development, city development, because you looks like very confident with the development. Yeah, thank you.
Mungkin saya jawab dengan bahasa Indonesia dulu. Terima kasih untuk pertanyaan Pak. Jujur saya juga mempunyai sedikit kegelisahan tentang itu juga. Tapi yang menjadi dasar kami adalah data. Jadi sebelum kita memproject the future condition, kita membuat sebuah validation. Jadi kita punya banyak data. Kita punya data di tahun 2020. Jadi saya pakai model analisis yang ada dengan data yang ada untuk predik di tahun 2020 juga. Jadi kita bandingkan data aktual yang di tahun 2020 dengan hasil dari model yang kita pakai di tahun 2020. Dan validasinya cukup baik karena mencapai angka 79%. Namun kembali lagi kita tidak bisa mempredik future kondisi di masa depan dengan sangat presis, karena apalagi terkait pembangunan itu sangat sensitif terkait policy kebijakan pemerintah, Pak. Kita terutama seperti yang Bapak lihat tadi di tahun 2020 pembangunan dampak dari perubahan dan cover karena pembangunan Nusantara itu tidak tercapture. Ya, tidak tercapture. Ini tiba-tiba lalu ada pembangunan yang dilakukan secara masif sehingga perkembangan build up areanya sangat signifikan. Jadi di situ tidak bisa di-capture oleh model yang kita pakai INN karena itu adalah eksternal faktor yang sangat-sangat dinamis karena tidak ada yang bisa memprediksi itu bisa disepakati begitu. Jadi confidence kami adalah data dan hasil validasi itu, Pak. Tapi kami juga men-state bahwa masa depan tidak bisa kita predik secara precise, tapi kita bisa predik dengan historical data yang ada. Ya, terima kasih.
Okay, we're gonna close this Q&A session. Thank you to Mr. Indra Aditya from. Okay, before continuing, we have a coffee break till 2:50. But before that, we're gonna have a photo session. So I would like to ask everyone in the audience to get closer to the mic.
I'm sorry, this is the seminar for the discussion of this new development city. So our discussion is most important. So I'm sorry, please check the program. We need to discuss. So after coffee break, for the session and the coffee break, we would like to ask all students for the recommendation for the new capital city. Maybe Dr. Idham has to leave and he needs to go back to field, but we will report him and JICA and Japanese government and Indonesian government, what is the recommendation, what we have to do for the new capital city. Okay, we already discussed this situation in ITB, Funding Institute of Technology. I will show this one later after the coffee break. And please give me every comment or question. I will take this session for 30 minutes. Okay, after this discussion is very important at this seminar. This is the purpose of this seminar, so we cannot skip. I'm sorry. So please take a photo and take a good rest, and after that, please give us many comments. Because, as I said in the morning session, our product strategy is by all including, not only Idham-san, but also students. Okay, you do not say PU and other organization is a responsibility for the plot. No, it's totally strange. Okay, you have the responsibility for the plot management and the future new capital city. Okay, do not rely on the president. Okay, you have to do it by yourself. Okay, okay, thank you.
Okay, thank you. Okay, now we're gonna have a photo session. So please, everyone, come to the center to take a photo. From the left side, you can go here, and from the right, please. Stand up, please. Everyone get closer to the center. Yang nggak cukup kursinya, nggak apa-apa berdiri aja di samping-samping. Tolong yang di sini, penuhi depannya dulu nggak apa-apa. Sampai barisan Abi. Dipercepat. Boleh maju ke depan.
Dadung, arahin.
Oke, kita pandu ya. 1, 2, 3. 1, 2, 3. Ganti gaya. Change the pose. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. We have finished the photo session, so we're gonna take a break till 12:50. Thank you. We're going to continue the discussion and the third session in 2:50. Thank you.
Diskusinya jadi setengah jam. Ini spot sama ini aku kasih 25 menit cuman kayak buat jagaan aja. Ini nggak boleh kita jaga semua. Oke nggak?
Enggak, yang manduk.
I cannot do this. Coba lah. Nah,
Awas awas
Maaf guys, ditemukan kunci motor. Kalau ada yang kehilangan kunci motor, boleh ke depan ya. Kuncinya agak segitiga gitu.
Kunci segitiga.
Kok bisa hilang?
Balik. Belum selesai.
Gak boleh bang.
Absennya sampai akhir. Absennya sampai akhir. Tar itu marah.
Bapak kita.
Iya.
Kita juga pengen balik tahu.
Sebenarnya tuh ini kita yang undang mereka.
Mi, gue punya acara tolong ke tempat dong ya. Tolong ramein dong.
Mereka suruh nanya kita aja
Ini mau pizza.
tapi kan udah ada PSP. Iya sih. Maksudnya ini sebagian besar kan masalahnya flu ini. Ya. Iya. Tapi PSP-nya pun soal lah. Masih tengah. Aku PSP antara hidup dan mati aja. Tapi aku ngerti pas mereka ngomong yang das itu aku ngerti. Aku kayak aku kan penanya tadi sebenarnya kan.
Sama nanya. Nah, dari tadi disuruh tanyain, nanya cuma depan-depan aja. Itu si profesor.
Ngerangkai kata ya kan. Kan ada transkrip.
Nah, dia tuh kayak mau membangun buat diskusi nanti gitu loh. Kayak kita bakal ada diskusi ya. Jadi nanti gini gitu.
Soalnya katanya ini kan by all, jadi kalian semua harus. Yes. Kan nanya kan mereka pindahin ibu kota ke IKN kan gara-gara airnya banyak. Tadi kan itu juga sama kayak di sini di Jakarta. Di Jakarta kan air tanahnya banyak kan. Itu tadi bedanya itu bisa sampai kapan kira-kira? Kayak gitu batas amannya mereka gitu. Sampai gimana?
Ini terusnya nggak masuk.
Kira tuh kita yang undang mereka.
But you understand, right?
Maybe
Kita coffee break. Oh, coffee break. Ya, di sampai 14.50.
udah mau.
Oh, beda sini.
Ini kopi break mana kopi? Kopi apa? Katanya kan kopi break kan lah kopi apa? Aku kira tuh besok kita yang break kan. Pantesan disuruh datang kawan. Sampai jam berapa sih? Tawang. Ya, masa ini sekarang sampai jam berapa? Jauh lu kan 2.50. Lu berapa cara namanya? Gede dong.
Buat diskusi nanti bakal ada PPT.
Ada sedikit, jadi biar diskusinya terarah, sisi kami buat sebuah PPT.
Itu nanti udah ada di
Udah.
Tadi kan di IKN kan tadi aku ngomong airnya kan banyak ya.
Mana?
Kan tadi kan di IKN untuk itu banyak sekali ada begitu. Biasanya kan sama kayak ini tuh banyak ada bosnya kan sama. Nah itu secara itu bakal terjadi nggak di Kalimantan?
Tergantung. Sebenarnya yang membuat Jakarta itu tenggelam karena kan groundwater
Ya di serap semua kan.
kita keluar di semua tuh jadi di tanah gitu. Jadi rongga. Harusnya tanah itu kan mengandung air, udara dan tanah itu sendiri kan. Akhirnya kita ambil tanah itu bakal lebih jadi padat, jadi dia turun.
Wow.
Melakukan hal yang sama. Ya sama juga permasalahan terjadi. Jadi kalau di kota-kota lain, groundwater use untuk kebutuhan sehari-hari itu nggak dibolehkan. Jadi mereka mengandalkan
PDR kan.
jadi dari jam itu mereka buat dari area juga berpikir jadi gue menang ya.
Lagi kali 2 menit lagi.
Telat dan antisipasinya juga lambat kan.
Iya.
Jadinya di Jepang itu di Tokyo gue sama dulu pernah mengalami land subsidence.
Ladies and gentlemen, I would like to inform you that we're going to start in 2 minutes, so please find yourselves in your minds.
Ngasih perkuatan itu tancapin ke tanah isi dari dalam atau
metode injeksi. Jadi mereka masukin beton ke dalam tanah-tanah yang banyak metode sebenarnya. Mereka pakai beton atau masukin sitpa. Ya,
sprint terus. So we will finish 4.4. Injeksi ke tanah ini mereka betonnya itu perkuatan beton ekstern atau memang
ada beton khusus. Beton khusus bukan beton untuk bikin beton biasa enggak. Jadi dia cuma pasta doang.
Tapi itu pastanya itu pas di dalam tanah itu
Lebih
sebenarnya
mengeras.
mengeras. Itu kan nggak merusak apa komposisi tanah ya kan? Maksudnya kayak apa? Kan
Dia bikin dia
mineral-
didesain ramah lingkungan.
Jadi mineral tanahnya tetap ada di nggak kecampur sama kan. Kalau biasa kan kita pakai buat jalan kan dia merusak apa isi tanah kan sebenarnya.
Kesuburan.
Makanya mungkin nanti kayak aku buktikan tuh harusnya dan kuliah tuh mereka harus ngambil PDAM sih, udah mungkin saya.
Harusnya, bukan ya mungkin sebuah kewajiban sih untuk sebuah kota yang sustainable.
Nah itu kan mereka udah ngeplotting damnya kan, bendungannya kan. Nah itu tuh dari itu mereka itu bakal ngalirin airnya dari situ atau mereka sirkulasi ulang air yang udah dipakai?
Kayaknya dia ngambil setahu saya ngambilnya dari bendungan sih. Jadi bendungan dibikin pipa terus dari ke PDAM, terus hasil olahannya itu dibuang, tapi dijernihin dulu sebelum masuk ke sungai lagi. Dibuang ke sungai. Jadi gak direuse.
Dibuang, tapi dimurniin dulu ya.
Dijernihkan.
Ladies and gentlemen, our agenda is gonna begin shortly. Well, now that everyone has gotten in their seat, we will continue our agenda, which is a discussion about the new capital city, Ikn, and Jakarta. So I would like to ask Professor Shuichi Kure to take over the discussion.
Thank you very much. This is the main topics for this seminar, and we already got recommendations. Our new capital city will move to the Kalimantan, I believe. And also this Jakarta city, you will face many floods every year, right? And traffic jam and everything. So, under climate change situation, their situation gonna be very tough. So, we have several recommendations. This is a recommendation from ITB student, Bando Institute of Technology. I'm expecting much more recommendation from you guys. Okay. So, first of all, we have to continue the scientific research. Now, satellite is ongoing. Satellite is a very important big project with Japan and Indonesia. But this is a major earthquake and tsunami in coastal zones. And next, Asia, we may apply this one. And also collaboration with Japan and other countries are important. Like this seminar, we came from Japan, but please note, today, Mr. Akbar and Indra, they did a very good presentation. Don't you think so? And after my talk, Japanese student will make a presentation, but not so good, so do not expect too much. Their presentation is much better. So what I would like to say is those research should be conducted by Indonesian students. Okay, don't rely on China or don't rely on Japanese. Okay, don't rely on the Netherlands. Okay, you have to do it by yourself. Okay, in order for that, what Japan can do is invite you guys to our country and to educate and going back to, today, this Idham show many hazard maps, right? And the methodology is very similar to the Rizaldi because he learned from Japan, okay? So, and what we discussed is the data. In Indonesia, we don't have the data. So, we recommend the radar system and the mini radars in the new capital city and gauge station and flow discharge during the flood. This is the observation and also about morphological data, fine resolution DM, and this is important. But today, Idham-san showed satellite image can catch the flood inundation based on the Sentinel-2. Yeah, that is very useful too, I think. Also, Rizaldi-san mentioned dynamical downscaling is important, but Dr. Fajar answered statistical downscaling is suitable for this country. And also, already Idham-san made a presentation about flood hazard maps.
Also, Idham made a flood presentation about the flood early warning system. Those technology is important. And also, you can learn from the Japanese model like rainfall runoff inundation model or non-structure and structure measures. It's already Rizaldi is mentioned and recommended. You need a non-structure and a structure measures. And others, and of course, land use control and management are important. Also, environmental aspect. New capital city Kalimantan is very, very important for the environment. There are many precious species, precious birds and precious insects. But if we build our new capital, they will be died. So how to protect the environmental situation is also important. And other aspect, for example, Rizaldi mentioned in ITV, education is most important for Indonesian students, people, not only Indonesian people, but also Asian people. Also, political and economical situation should be stable. So, those are the recommendations from ITV students and ITV professors. So, maybe 2014 from now, 15 years later, you guys will be about 40 years old. Okay, you will be a whole adult when the new capital will be constructed. So, if you have any recommendation to add, please raise your hand. Don't be shy. Okay, in any word is fine. Indonesian language or Japanese language is fine. And then I would like to ask Dr. Fajar for final recommendation. Okay. So, is there any recommendation? Maybe deeper? Indonesian language is fine. Okay, first, then I will ask Idros.
Yeah, I think for Indonesian new competency, we have a lot of homework, I think, because yeah, first we need data, and then after we have data, we need to assess and evaluate future condition of land use and of flood or other disaster in future. Yeah, but for me, the most important is planning. What kind of city that they want to adopt? Yeah, many city like Swan City in China is really effective and efficient to reduce and prevent flood in China. And that's really good idea if that could be applied in the new capital city. But maybe they cannot use 100% of the concept, but they can modify and adopt by considering actual condition of new capital city, and also to prevent the same mistake that they have done in Jakarta. They use much groundwater and then land such that happen, and to prevent that they need to make regulation and make infrastructure to prevent people using groundwater again. I think that's promising.
Thank you very much, Indra-san. I strongly agree with you. He mentioned 2 points. One is you guys have to the dream and the vision. What do you want for the new capital city? You have a very bright and open future. You know, in Japan now our economy is down and the population is getting down, but you guys' population is increasing, economy is increasing. I'm sure 2100, Japan and Indonesia are going to be opposite. You know, first, okay, population is your population is getting increase. Japanese population is decreasing. Okay, situation going to be changed. Your future is very brilliant. So he mentioned you need a view of the future. Okay, what kind of city do you want? I heard Bandung was designed like a Paris. I'm not sure, but he mentioned, okay. So
what kind of city do you request for the capital city? And he mentioned that such kind. And second point he mentioned is regulation. Okay, groundwater pumping, land use control. We have this. He mentioned he needs some strong regulation. Then that will be provide sustainability and the environmental protection. I strongly agree. That is very, very important addition for this one. Okay, next I would like to request Rizaldi. Okay. Okay. Actually, we should not ever forget about the history, right? What I present in here, actually, I talk about Jakarta. Jakarta has been flooded since before our independence day. It means that actually until now we never learned. So that much, yeah, we learned, but not that much, because we still could find several locations in Indonesia also got flooded until now. It's not only Jakarta. Jakarta is one point because it's our previous national capital city. But actually, many locations and before the new capital city, that location also got flooded actually. So we should learn about what we already done. Yeah, maybe not us, but our ancestors, they already done. What makes Jakarta already covered by built up? We have to learn about that. We should have a better understanding about how this world works. As engineer, we should think based on science. After we understand how science works, we should find the solution. That's how we should think to solve every problem in our nations. Maybe in future you have a chance to be a politician. Then after that you can think as a politician. But right now, as a scientist, as an engineer, we should think as a scientist and engineer. We think by science and try to find the solution by engineering solution. So learn about the history, find out what the driven factor of flood. There, maybe you know because you have a degree in civil engineering, you knew why flooding happened, but outside there, maybe there's still another people don't understand about this one. When it got flood, the problem is not there, but also us. The responsibility is they who knows about the knowledge, not they don't know the knowledge. So we should learn about the history while you are still young, we are still young. And before the national new capital city is undergoing under construction, we still have to consider criticize what the government should do, give our idea like what we are doing now. So we try to tell them, make them remember about what already done in other place about flood. So knowledge about flood, and also make a new innovation, especially natural or environmental safe solution for flood. Not only rely on the structural, but also we have to combine them. So innovation is also important. And like I said about the historical, so to know the history, we should record every event that already happened. So the culture to record the historical event to get a better understanding for the future problem.
Thank you very much, Rizaldi. I strongly agree that history is a very, very important to look forward the future. We should remember the history. Japan, after World War II, we regret what we did and we change. Okay, we apologize in Indonesia what we did, but we still remember what we did and we are looking for the future. We will never do such kind of situation. And and also he mentioned technology. Okay, for the future now, many technological innovation is ongoing. So there is new unbelievable technology can be happening within this 20 years or something. I strongly agree. Such kind of technology should be introduced in the new capital city. Is there any addition from Indonesian student? No? Oh, for example, very good, very good, very brave.
So the question is about our recommendation for the new capital city, right? I probably can explain in advanced way because I'm second year students, but as a Jakartans myself, I will explain about what happened in Jakarta. Myself, I see about the history in Jakarta that the Dutch create the canal. They're not thinking about the future or the after effect of this canal. So I hope that the capital city will thinking not just about right now as aspect, but after effect of the constructions. And then about the groundwater, as Jakarta myself, I really hope that I'm not using this groundwater, but because the access of another water is so hard and it's really crowded. I'm living in quite, I can say slum probably. So the access of the water is so hard that the only thing that we can do as the civilian in Jakarta are using the groundwater. So I hope that the access of water in capital city will be happen easy access and another facilities that will be helping with those kind of aspects. And then one thing I hope that all of the politicians, all of the engineers that right now doing this project of this capital city, not only care about the construction, but also an ethic for the people in Kalimantan, because I see some non-ethical action for the Kalimantan civilian. So I hope they are really considerate about that. So this is my point of view as a Jakarta myself.
Very wonderful. Thank you very much for your very, very important point. I strongly agree with water availability. Yes, it's very easy. Don't use groundwater, okay? But we have to prepare other options. Yes, Jakarta is very, very difficult to find the water. Yes, so actually in Japan we constructed many dam reservoirs, and I heard in Jakarta now there are many dam construction is planning. So I don't want to discuss dam is required or not, but I think dam reservoir is very, very useful. So in capital city, I request PU and every organization, please first get water resources. Yeah, maybe Fajar, Dr. Fajar is know very well about this topic. And also third point, yes, we have to respect the people in Kalimantan. Okay, we have to show them that land is actually their land. Okay, so we have to respect each island and each culture and each religions. Okay, thank you very much for that very, very important point. And I'm happy you are brave enough to raise your hand. That will be most important point. Okay, thank you very much. Is there any other question? Our gentleman
You are ready?
Sure.
Oh, I think, from my point of view as a Jakarta myself, continuing from her point, I think how hard the accessibility to water is because the pipe is always dirty and get corrosion from the ground. I think the new capital city should maintain the pipe for the tap water itself because in here the tap water we cannot drink the tap water. Unfortunately, we don't have tap water like America, like from the faucet we can drink. In here we can do that because the water is still dirty from the effect from the pipe. And second, I hope the new capital city can adapt a new green city concept where the environmental aspect is we know is very important. We can use electric vehicle, like maybe we can build some railway route for the new capital city. I think it's just that from my point of view. Thank you. Yeah. Thank you very much. Very, very important 2 points. One point is the water distribution system, like a pipe, and this is very, very important. Also, in Japan, we are facing how to maintenance this pipe system, but yes, such kind of infrastructure is very, very important. So you should understand how the civil engineer is important in the world. Okay, so I assume, and also second point, what you mentioned is green city, yes. Green city is very, very one of the most important. And not only electric vehicle, but also some changing of our mind is very important. As you said, don't use a car or something like that. Not only adaptation for the climate change, but also mitigation for the climate change is also important. And unfortunately, Jakarta's air atmosphere is not clean. Yes, we fly from Japan to Jakarta, and if we look at the sky, it's very dirty. I can feel. But trust me, maybe 50 years later, our vehicles, technology, Rizaldi said, scientific innovation is now ongoing. So sky in Jakarta will be dramatically changed if you want. Okay, trust me. Okay. So thank you very much. So it's almost time to finish. So I would like to pass Dr. Fajar wrap up. What is the recommendation?
Okay, thank you for this opportunity. Yeah, there are many recommendations already mentioned by you, like how the indigenous or the local people should be considered during the construction of the city, and also this about the civil engineering and about how to learn history. Sometimes Indonesian people has maybe we can say short memory. Maybe previous, maybe now some maybe public figure do something wrong, and maybe next year we still love him or them, right? So this is like a short, so we should consider about the historical more about this in Japan. Maybe we have tsunami, Tohoku tsunami. They still have a school that affected by tsunami as museum. But Indonesia is very less about to remember about the the previous disaster. But this is okay. This is the point. But maybe my comment maybe is about my recommendation was most of all is how to construct the how develop the city with zero delta runoff. This is the point. Sometimes we construct with excess runoff. The problem that happened in our country is when we develop some city or maybe develop new, let's say new residential area, the number of the amount of water excess is more than the previous. So that's why it make a flood problem. This is maybe short term period problem is flood, but for the long term, because there are many water excess, so small amount of water infiltrate. Small amount of water infiltrate will be decrease the base flow in the river. So maybe my last recommendation about the how to make the when we construct the capital city make the zero runoff, delta zero runoff. Thank you.
Thank you very much. I will give it back to the chair.
What a wonderful discussion from everyone in this auditorium. Give a round of applause, everyone. All right, we will continue to our last session for today, which is about research on flood modeling and local adaptation to climate change. For this session, the chairman will be Mr. Akbar Rizaldi from Toyama Prefectural University. To Mr. Akbar, the stage is yours.
Okay, thank you. Thank you for
Thank you for your time. So next presentation will be presented by master student of Professor Kure, and he is in the last year. I would like to present Mr. Ryuto Fujita. You can call him Fujita-san. So Fujita-san, the time is yours.
Hello everyone. My name is Ryuto Fujita. Nama saya Fujita Ryuto dari Japan. Today I will talk about flood modeling and future flood projection based on D4PDF dataset in Toyama Prefecture, Japan. This is a presentation outline. First, introduction. River in Toyama Prefecture are known as rapid flow river in Japan. Joganji River is top level. As a result, a lot of damage is caused by erosion. Therefore, it is important to assess high-risk areas. Also, Japan temperature and precipitation are increasing due to global warming, leading to the increasing frequency and magnitude of floods. Hence, flood risk assessment based on future climate is important. Therefore, I decided my research question. How do rising temperatures affect Toyama Prefecture rivers? Let us do some analysis using future rainfall data. Next, study area. This is my study area. This research focused on first-class river in Toyama Prefecture. It is located in northwest of Tokyo. Next is research flow. This is analysis flow images. We calculate the phenomenon of rainfall flowing into rivers and predict whether flood inundation will occur. For example, rain falls in a basin and water flow into the river from the mountains and towns. This causes the water level of the river to rise. Rising water levels cause overtopping and erosion. Finally, breaking. We perform these analysis using future data sets to predict flood inundation. The next section describes a data set. First, rainfall data. Future rainfall data needs to analyze future climate impacts. Therefore, the forecast data called D4PDF is utilized. D4PDF is a dataset of ensemble climate prediction calculations. It is made JAMSTC, Tokyo Union, and Kyoto Union. It has global and Japanese scale data. Global scale data is 60-kilometer mesh data. Japanese scale data is 20 kilometers and 5 kilometers mesh data. 20-kilometer mesh data have various temperature rise patterns and many ensemble data, about 3,000 from 5,000 years of data. 5-kilometer mesh data provides less data but higher resolution than 20-kilometer mesh. Since the future cannot be predicted, the large amount of data is evaluated probabilistically. Next, bias correction of rainfall data. Because of biases in the forecast data, there are gaps from previously observed rainfall. Bias correction are made to reduce the bias in the data. I used Peony bias correction method and quantile mapping. Second, rainfall runoff. This is a rainfall runoff image. Rain flows over the ground and into river, like surface flow, subsurface flow, and underground water flow. Rainfall runoff require rainfall data, analysis model, runoff parameters for each land use, and land data. I use a model, and I use this model. The model is good at calculating water runoff from the mountains. This is land use data. The land use varies with age. Current climate use 2050 year land use data. Future climate use projected land use data. Runoff parameters for each land use. Required parameter for rainfall runoff models, like soil thickness, porosity, and runoff rate, are set for each of the 5 land use classification. Parameters are changed to match the observed discharge and determined by trial and error. Next, flood routing. calculation of how water flowing into a river will flow. Since soil and vegetation in river can impede the flow, the roughness coefficient is used to express the ease of flow. Flat routing required lateral inflow analysis model, river cross-section data, and roughness coefficient. I used this equation, a flat routing model. And cross-section data is based on actual measurement. Setting roughness coefficient, I use a D4PDF. D4PDF is indicator of vegetation distribution and activity. A comparison with the roughness coefficient of the high water bed in the maintenance planning documents. A constructed roughness estimation equation by NDVI. Next, result. Comparison of 20 kilometer mesh data with 5 kilometer mesh data. I created a return period graph of peak discharge. Peak discharge were calculated for each year, about 3,000 from 5,000 a year, as shown in this graph. And return period graph was created. Left graph is 20 kilometer. Right graph is 5 kilometer mesh data. Compared to the 20 kilometer data, the 5 kilometer data may have captured more extreme rainfall events. Next, comparison by bias correction method. I checked a difference due to bias correction. Left is Peony method. Right is quantile mapping. Some change in peak discharge rate was observed depending on this bias correction method. Future analysis will consider countermeasures using quantile mapping to assess the worst case scenarios. Finally, I confirm change in peak flow rate. This table is comparison of peak discharge rate between past experiments and temperature rise experiments. At 4 degrees Celsius rise, it is about 1.5 times higher, 1.1 times for 1.5 degrees Celsius rise. A summary. The 5 kilometer mesh rainfall data results were greater than the 20 kilometer mesh results. By limiting the temperature rise to 1.5 degrees Celsius rise, a peak discharge rate increased from 1.5 to 1.1 times. Thank you.
Yeah, thank you for Mr. Fujita for very interesting presentation. So unfortunately for this session, we will not conduct any question answer because we're limited of time. So, but I will tell you about why we want Fujita, and also the next presenter will to present to you. It has a relation with the opportunity to learn in Japan, study abroad. So you can see about what the master student in Japan do for their research. We can see that the advanced technology, advanced methodology, advanced idea creative idea to find the solution of the flood problem. So let's move to the next presentation. I would like to invite Ms. Hatsune Numazawa to present her presentation. Please give applause for her. Ms. Hatsune, time is yours.
Halo. Hai. Nama saya Hatsune Numazawa dari Toyama Prefectural in Japan.
Like this.
Minta.
Pointer. The pointer. Pointer. Oh, sorry.
I'd like to talk about local adaptation to climate change based on several countermeasures. Oh, ありがとう. Presentation outline. First is introduction. Japan's temperature and precipitation are increasing due to global warming. The frequency and magnitude of floods are increasing. So, flood risk assessment based on future climate is important. And now, in Japan, integrated basin management for flood control is being promoted. This is like that map, the cooperation of all stakeholders in any kind of flood place around the basis for reduce damages. Adaptation countermeasure like this example. Objective of my study, quantitability. Evaluate adaptation measures through flood inundation analysis in river of Toyama Prefecture. This is my study area, Japan, Toyama, and Toyama A-class rivers, Oyabе River, Joganji River, and Jinzu River. These rivers are very rapid. Next is research flow. Connection between rainfall runoff and flood routing and flood inundation, flood damage costs, and evaluation of B by C. And then flood inundation analysis with adaptation measures. First, rainfall runoff is used before PDF, past experiments, and 4 Celsius rise runoff data, especially 150 and 350 years probability events we used. And next, flood routing is used river information like length, cross-section, Manning's runoff, roughness coefficients, setting initial conditions like this. And flood inundation is used elevation data, Manning's roughness coefficient data, and embankment bridge conditions data, setting initial conditions and time and grade steps. This river information data, this is cross section, it is flow and Manning's roughness coefficient and flood and when flood occurred, flood flow and Manning's roughness coefficients in flood plan, and this is embankment bridge conditions. Flood routing in river is used like this equation, one-dimensional unsteady flow model, and flood inundation simulation is used this equation, unsteady two-dimensional flow equations. And as this model, result of flood inundation simulation is here. Left is past experiments and right is 4 Celsius rise. If we don't take action like this, the future will be so much more damaging. So to prevent this damage, we have to consider what is the best adaptation to climate change based on several countermeasures. We think about vegetation cutting in river channels and construction of polyfill dam. First is vegetation management. This is before in river, and right is after cutting vegetations. We changed Manning's roughness coefficients from high values to low values. This point was from before study, and after the vegetation cutting, this model. Next is polyfill dam. This is construction of polyfill dams. We use the model of Chai et al. Like this. This model is one-dimensional polyfill dam model. We considered 5%, 50%, and 100% implementation rate. And results of flood inundation and simulation. Left is vegetation management, and right is polyfill dams. This result is gap of depth from nothing adaptation. From this, the result, vegetation cutting in river channel and construction of polyfill dam can reduce flood inundation area and water depth. So we next to consider cost. Calculation of flood damage cost. First, flood area multiply assessed variation costs. This assessed variation cost like this types, these 5 types. And depth multiply damage rate. For example, depth is 0.5 meter, but multiply damage rate 0.3. Depth is 1 meter, multiply damage rate 0.5. So depth, the higher depth, the higher damage rate. And multiply assessed variation costs. So we can know flood damage costs. And this is results. Rates of damage cost reduction due to left is polyfill dam, right is vegetation management. According this result, damage cost reduction rate shows polyfill dams and vegetation management are effective in the Oyame River. Next, finally, evaluation of B by C. First is evaluation of benefit. We calculated the annual damage cost reduction based on 150 and 350-year probability events. Calculation of expected annual damage cost reduction like this, use this equation. But this formula usually use multiply probability years, but since it cover only 2 years, so really like this higher, but so this situation, like this linear increase. Next is cost. Vegetation management, once every 5 years, all vegetation in the area to be evaluated is cut down. And management method, willow and grass separate we consider. Simple roughness coefficient estimation formula by NDVI is used. And Polyfield Dam, the Polyfield Dam shall be rebuilt once in every 80 years. Construction cost of flood control dam per storage capacity like this cost. Polyfield dam construction cost is this. Results of B by C. Cost effectiveness. Polyfield dam is higher than vegetation management. The large spread of polyfield distribution in Toyama Prefecture and the cost of installing and maintaining polyfield dam is small. The effect was about twice as large in case 0.03 and 2.02. The more cutting vegetation, the higher the B by C. And expect for the Jinzu River, the more implementation rate, the higher the B by C. Especially in the Oyabe River, which has high score in both evaluations. But now, ignore the cost of treating and transporting vegetation. So this point, when we consider, we expected to approach 1.0 for the Oyabe and Jinzu rivers. And Polyfield dams, installation rate is set higher than reality, so we have to consider realistic implementation rates. Conclusion. Objective my study, quantitatively evaluate adaptation measures through flood inundation analysis in river of Toyama Prefecture. So we carry out future rainfall is used for flood inundation analysis with adaptation measures, calculation of flood damage costs, and we calculated B by C. As a result, in the Toyama Prefecture, Polyfield dam is provide as effective countermeasures, especially in the Oyabe River, which has high score in both evaluations. And next, we should consider, we calculate more events and rethinking how to set up. Thank you for attention. Terima kasih.
Okay, thank you, Ms. Numazawa, for your very insightful. Okay. The end of the presentation of Ms. Numazawa already also the closing for my session, so I will give this time to our master ceremony. Thank you for your attention. Give us applause again.
And that concludes the last session for today. Okay, we've unfortunately came to the end of this event. Even though there was a lot of technical issues at the beginning, but at least we ended on a good note. On behalf of the Symposium Committee, we would like to say thank you for your active participation today and have a great rest of your day. I'm Rania, signing off. Wassalamualaikum warahmatullahi wabarakatuh.